Szanowni Państwo,
Ladies and
dostojni goście,
gentlemen,
jest mi
distinguished
niezmiernie miło
guests,
powitać
it's a
Państwa
big
na
pleasure for
konferencji
me to
10
welcome you
lat
to the
Polski w
conference
ESA,
10
wczoraj,
years of
dzisiaj
Poland
i
in
jutro,
ESA,
organizowanej przez
yesterday and
Ministerstwo
today,
Rozwoju i
tomorrow,
Technologii,
organized by the
Polską
Ministry
Agencję
of Development
Kosmiczną oraz
Technology,
Związek Pracodawców
Polish
Sektora Kosmicznego.
Polsa and
Rok
Space
2022
sector.
to szczególny czas dla polskiego
2022
sektora
is a very
kosmicznego.
special
Mija
time
bowiem
for
10
Polish
lat
space
członkostwa
sector.
Polski w Europejskiej Agencji
We've been
Kosmicznej.
members
W
of
tym
ESA
czasie
for
polskie
10
podmioty
years. During
rozwinęły
that
skrzydła
time,
i ponad
Polish
300 z nich na co dzień współpracuje z
entities
ESA. W tym
started to
150
cooperate
bierze
with
bezpośredni
ESA.
udział w projektach
150
kosmicznych.
participate directly
Polska
in
uzyskała
space
dostęp
projects.
do infrastruktury
Poland
naziemnej i
received
kosmicznej
an
oraz
access
współpracuje z
to
kosmicznymi agencjami
infrastructure
narodowymi
and
i
cooperates
największymi
with
firmami
national
sektora
space
kosmicznego.
agencies and the biggest
Polskie członkostwo w ESA to
corporations.
także możliwość rozwoju rodzimych
Polish
technologii,
memberships
znaczący
in ESA
udział
means
w łańcuchu
also that
dostaw
we can
projektów
develop
kosmicznych,
the
rozwój
projects,
kadr i liczne
personnel,
projekty
and to
edukacyjne.
take part in many
Przypadający czas to
educational
dobry moment
projects.
na
This time
dokonanie
is a good
podsumowania,
moment
dyskusję
to
i wyznaczenie
wrap
celów
up
na przyszłość.
our membership,
W trakcie
summarize
dwudniowej
it and
konferencji
set
o
forth new
osiągnięciach
goals.
i
During the
przyszłości
conference
polskiego
about
sektora
the
kosmicznego
achievements and the
będą
future
rozmawiali
of Polish
zaproszeni goście
space
reprezentujący
industry
świat nauki,
will be
technologii,
discussed
branżę kosmiczną, a
by
także
different
liczna
guests
reprezentacja
representing
dyrektorów z Europejskiej
various
Agencji Kosmicznej.
sectors,
Zanim to nastąpi,
agencies,
zapraszam Państwa do
companies
obejrzenia
and
filmu
institutions.
zatytułowanego
And before we
10
do
lat
that,
Polski w
let's
ESA.
see a movie showing you 10 years of Polish membership.
Szanowni Państwo, proszę wygodnie usiąść i zapiąć pasy. Podróż po technologiach kosmicznych rozwijanych w Polsce zaraz się rozpocznie.
3, 2, 1.
W pierwszej kolejności zatrzymamy się przy polskich rakietach suborbitalnych Perun i Bursztyn. Będą one mogły transportować towary w przestrzeń kosmiczną, umożliwiając na przykład badania naukowe w mikrograwitacji. Po wykonaniu zaplanowanej misji rakiety wrócą na Ziemię. Dzięki spadochronom miękko wylądują w określonym punkcie. W obu rakietach zastosowane są ekologiczne rozwiązania. Perun i Bursztyn posiadają napęd hybrydowy, który działa w oparciu o materiał pędny przyjazny dla naszej planety. Przenosimy się w tempie odrzutowym do powstających systemów satelitarnych oraz aplikacji do przetwarzania dużych zbiorów danych z obserwacji Ziemi. Polska pracuje nad własną konstelacją satelitów obserwacyjnych Mikroglob. By w pełni korzystać z ich potencjału, opracowuje Narodowy System Informacji Satelitarnej. Będzie on służył monitorowaniu naszego kraju i zwiększy wykorzystanie danych satelitarnych służących gospodarce i społeczeństwu. W polskim przemyśle kosmicznym kładziemy nacisk na niezawodność. Proszę zwrócić uwagę na zaawansowane oprogramowanie, testujące systemy i podsystemy obiektów wynoszonych na orbitę. Zabierzemy teraz Państwa do świata robotyki planetarnej i orbitalnej, w której specjalizuje się spora grupa rodzimych podmiotów. Opracowują one koncepcje, projektują i budują roboty, które biorą udział w misjach kosmicznych. Projekty, które zostały przez nie zrealizowane do tej pory, to urządzenia do zbierania próbek, testujące, podzespoły ramion robotów, modele matematyczne, systemy sterujące i wiele innych. Obszar aktywności polskiego sektora kosmicznego to pokaźna konstelacja mechatroniki, elektroniki i informatyki. Całą branżę w Polsce reprezentuje blisko 380 firm, ośrodków naukowych i grup badawczych. Wiele z nich jest beneficjentami i bezpośrednimi dostawcami Europejskiej Agencji Kosmicznej. Współpraca z ESA to nie tylko wsparcie finansowe i dostęp do infrastruktury agencji, ale także możliwość zdobycia cennego doświadczenia i zagranicznych kontraktów. Zmieniła się też skala i poziom naszego udziału w międzynarodowych misjach oraz projektach badawczych. Członkostwo w ESA stało się impulsem do powstania Polskiej Agencji Kosmicznej. Kosmos od wieków rozbudza ciekawość ludzi. Popycha do osiągania ambitnych celów, przekraczania kolejnych granic, zmieniania świata, jaki znamy. Stanisław Lem powiedział: nie chcemy zdobywać kosmosu, chcemy tylko rozszerzyć Ziemię do jego granic. W tej pasjonującej kosmicznej podróży ma swoje miejsce również Polska i technologie, które tworzy rodzimy sektor kosmiczny. Dziękujemy za wspólną podróż.
Jest mi niezmiernie miło zaprosić
Ladies
na
and gentlemen,
scenę
it's a big pleasure
podsekretarz
for
stanu z
me to
Ministerstwa Rozwoju
welcome
i
the
Technologii,
Undersecretary
panią
from the
Kamilę.
Ministry of
Zapraszam.
Development and Technology, Kamila Król. Ladies and gentlemen, this is a huge pleasure for me to welcome all participants of today's conferences celebrating 10th anniversary of Polish membership in ESA. Especially I would like to welcome the representatives of the European Space Agency, European Commission, as well as Polish Parliament. It's a great honor for me to see so many entrepreneurs, representatives of science and public administration who are actively involved in developing space activities in Poland. And this is a special occasion because we are celebrating the 10th years of Poland's membership in European Space Agency. Just as an introductory, this is a very special tool to support innovations, development of the economy, improving the efficiency of public institutions. Space sector also stimulates development of new technologies as well as innovations implemented in space sector are also applied throughout other fields and areas, improving their competitiveness. Well, interest in space in Poland has started at the end of 15th and beginning of the 16th century. Of course, we all know that during that time, the astronomer Nicolaus Copernicus worked there, and he actually changed the whole understanding of the space and solar system. Later on, the mathematician and constructor, he observed the celestial bodies and moon. Mr. Szymanowicz, theoretician who prepared the basis for the rockets. Well, Polish presence in space started in 1960s, 1970s. At that time, Poland was developing the construction of meteorological weather rockets called Meteor. The most advanced model of this rocket was Meteor 2K. In October 1970, it was launched into a record high level, 90 kilometers. This type of rockets reach the borders of the space, and they've been applied to sample, to probe the space. Later on, we launched the satellite Copernicus with the first Polish research instrument. 5 years after that, the first Polish citizen, Mirosław Hermaszewski, went into the space for 8 days, and he circled Earth 126 times. And that was a record that was approved by the International Federation of Aviation. In the 1960s, the Center of Space Research took part in researching Halley comet, and AGAT computers were used for that, and AGAT computers were also a Polish product. In 2018, on the 13th of February, during the first mission of a vegan rocket, Polish artificial satellite Eutelsat was launched into the orbit of Earth, and it was constructed by scientists from Warsaw University of Technology. When it comes to Poland's cooperation with ESA, well, it dates back to the 1990s. In 1994, we signed an agreement for cooperation connected with the peaceful use of space. In 2007, another important event took place when we signed the agreement between European cooperating member states, which was next step in our path to membership in ESA, which happened in November 2012, which also helped us to build a space sector in Poland. That means participation in projects and programs run by ESA. It was also important to gain the access to infrastructure, education, trainings and workshops. These memberships opened Polish sector, space sector to new possibilities, but our space sector fully used this chance and continues to do so. Ladies and gentlemen, I'm sure that this two-day-long conference will be a great opportunity to discuss the biggest successes connected with Poland's membership in ESA, as well as discuss the challenges that we still face. The Polish space sector is one of the most advanced technologically industries, which is more and more important for Polish, European and global economy. Poland has a potential, scientific R&D potential, and our expertise in space sector are increasing day by day, and that helps us to become part of this very innovative activity. We need to stress that our membership in ESA helped us to develop a space sector that goes beyond the science world. Today we can say that we created a new industry which bases mostly on Polish technologies and inventions, and it is noticeable and noticed by the leading international companies. With the help of our cooperation with ESA, we've been implementing many objectives from our Polish space strategy that was approved in 2017, and this strategy set forth the most important objectives and priorities for the development of this area in Poland, as well as instruments that will be necessary to implement them. So international and internal instruments, and one of those instruments is the national space program that is being prepared right now. Tomorrow we will have another important step that will help us to develop the space industry, but it will also be connected with the presentation of our strategy. We will sign the agreement between the ESA and the Agency for the Development of Industry, and it will cover creation of centers, business centers in Poland, which will help and support startups that want to link their future to the space. I'd like to thank the representatives of ESA for the possibility of joint implementation of projects. Because of this cooperation, Polish space sector is one of the most dynamically developing sectors of the economy. I am also convinced that this conference will be a great place to share experiences of the industry, NGOs, science world, experts in space industry, and moreover, it will be a great opportunity to start new contacts, new cooperations on local markets, on European market and on global market. Well, without further ado, I'd like to wish you good discussions. Thank you.
Thank you very much, Madam Minister, and I'd like to invite to the stage the President of Polish Space Agency, Professor Grzegorz Wrochna. Madam Minister, the MPs, the guests from the European Space Agency, dear friends from the Polish space sector. We are meeting here today to celebrate the 10th anniversary of Poland's membership in ESA. Like Madam Minister said, Poland has been in space for half a century. We sent the apparatus and we had General Hermaszewski, the first person in space who is today with us. But the modern era of our space expansion started 10 years ago with Polish accession to ESA. Thanks to that, over 80 missions were equipped with the Polish apparatus. Over 100 technologies were developed. The entire space sector was developed. That comprises almost 400 companies, several dozen specializing in space technologies. I'm not going to discuss these successes in detail because they will be best described by their creators, by the institutes, by the companies. You will have an opportunity to see how far they went thanks to the partnership with other entities in the European Space Agency. A couple of words about the future, because the future seems fascinating. We are living at a breakthrough moment for the space sector, which I like to compare to the 1990s as regards the IT sector and Internet. Back then, the Internet was a technology available only to experts, only to institutions, be it military or scientific. And then, suddenly, we all started using the Internet together. We are seeing a similar development of space technologies. We use them on an everyday basis, sometimes without realizing, but I believe that you are not the ones to be convinced. Today, satellites in the orbit, that's an infrastructure that the country needs as much as it needs roads, broadband internet, or 5G internet, or airports. This is something we need for our everyday life, and we need to build this infrastructure. It costs millions, but it will generate a billion for the country. €1 invested in space technology will generate several euros to the economy. We hear such estimates, but these are just the direct results. But the infrastructure, the satellite infrastructure for the observation of Earth and navigation, telecoms, it really has a chance to generate billions. Let us just imagine that thanks to this infrastructure we'll have 10% bigger harvest in agriculture, 10% less losses due to floods, 10% less forests will be burned. These are billions, ladies and gentlemen. So it is worth investing millions to gain billions. And what is the role of the European Space Agency here, ladies and gentlemen? If we look at the development of technology, it's quite easy to obtain funds for research works, for the development of new technologies. But in order for the technologies to be implemented as a market product, as a service, much bigger funds are needed, which usually the small companies, the startups that develop the new technologies do not have. This is frequently called the valley of death, because between the low and high technology readiness. And the European Space Agency provides a bridge over the valley of death, because on the one hand there is public money invested in the implementation of these technologies, and on the other hand this is a commercial order. One has to win a tender and deliver a product or service that is certain to work. And thanks to that, the different companies that are established sometimes even at universities, that are established established by students and that develop the technologies from scratch, frequently very innovative technologies, have a chance to develop to become big market players, which we are seeing today. So, what are our expectations from the next decades of Poland's membership in ESA? We expect that our companies will be able to build not just small subsystems but whole satellite systems, or the key subsystems to be used in all the missions. That is our hope. That is our hope for the Polish space sector, and certainly for all of us, we wish for the call for the astronaut that was started a year ago by the European Space Agency to the team of European astronauts. We wish that a Pole is selected. We hope so. Thank you. Thank you, President. And now I'd like to invite to the stage the President of the Association of the Space Sector Employers, Paweł Wojtkiewicz. Good morning, ladies and gentlemen. Madam Minister, the MPs, the representatives of the European Space Agency and the European Commission, dear colleagues. On behalf of the companies and institute members of the Association of the Space Sector Employers, I want to welcome you to today's conference. Also, I want to thank Madam Minister and the President of the Polish Space Agency for organizing these 2 days of the conference together. Actually, a lot has been said already, but this is true that Poland's accession to the European Space Agency was a very important moment for the Polish space sector. The time of Poland's accession to ESA is also the time of the establishment of the Polish Association of the Space Sector Employers. It was established on the 31st October 2012. This fact proves a very high business maturity and industrial maturity of the entities that want to operate in the space sector, and that back at the time noticed that the European Space Agency can be like a propulsion for the Polish space sector. There are many other factors for which the association was established and for which Poland joined ESA, but I believe that the most important factor is cooperation, because without good cooperation of many different groups, without cooperation of institutes and companies, and without the cooperation of individuals, back then at 2012, the accession to ESA and the establishment of the Association of the Space Sector Employees would not be possible. So I wish you fruitful cooperation, ladies and gentlemen, for the next 10 years. And I believe that looking to the past, we can talk about the future. 10 years, that is a lot of experience. We have our experiences both from ESA and from running businesses in the space sector. I believe that through the next 10 years, we will use this experience well for the space sector in Poland to develop. I wish you all fruitful meetings and fruitful talks during the 2 days of the conference. Thank you.
Thank you very much, President, and I would like to wish you all the best because of the 10 years of membership. Ladies and gentlemen, now the time for the Director General of the European Space Agency, Josef Aschbacher. He will be connected remotely with us.
Dear colleagues and friends in Poland, I would like to convey my best regards to the event celebrating 10 years of Poland's membership in ESA. 10 years of Polish membership in ESA equals 10 years of benefits for Polish companies, being part of breathtaking space missions, developing leading-edge technologies, and gaining attractive industrial contracts. Space benefits the economy as a whole, BNT services, Copernicus, agriculture, security, and so on. The global sector is growing. Europe and Poland in particular are part of this development. This is the moment to boost the Polish space sector and create tangible increased value. ESA's upcoming council meeting at ministerial level, CM22, is a prime opportunity to do so. CM22 will be the milestone to set out our ambitions and plans for space activities for the next 10 years of Polish ESA membership. Poland's future in space is bright ahead. I look forward discussing this with you in person tomorrow. Thank you and see you tomorrow.
Woli wyjaśnienia, jak zresztą Państwo słyszeli.
By way of explanation, as you heard, Director Aschbacher will be joining us tomorrow to celebrate Poland's accession to ESA live. As we have heard, the history of Poland's exploration of space reaches back to the discoveries of Copernicus, maybe even further. With every decade we see and understand more. To the stage, I'd like to invite the director of the Space Research of the Polish Academy of Sciences, Iwona Stanisławska, who will discuss this topic. Good morning, ladies and gentlemen, Madam Minister, President, the MPs, dear colleagues. Ladies and gentlemen, dreams about space have accompanied man forever. In the modern times, the myth of Daedalus and Icarus was transformed into the concept of Leonardo da Vinci's flying machines, and suddenly the world began to expand rapidly. It is worth quoting the words of Copernicus from his work De Revolutionibus. Among the numerous and diverse arts and sciences, the most beautiful and worth knowing are the sciences that deal with the miraculous revolutions in the universe and the course of the stars, and the causes of all other phenomena in the sky, and finally explain the entire system of the world. And what is more beautiful than heaven? Polish research of the sky, one of the first names here, was Copernicus and the modern concepts of the beginnings of the solar system, including Earth that revolves around the Sun, circles the Sun. According to Copernicus, the world, several years ago, the European Commission used Copernicus's name for the Copernicus program devoted to the observation of Earth. It is worth seeing the probable face of Copernicus. We can see it in the slide. This is a portrait taken towards the end of his life.
Coś mi nie idzie, przepraszam. Tu może trochę więcej szczegółów.
A bit more about the details right now. Maybe I can tell you about more about this beautiful story told by Madam Minister. Several years after Copernicus, we had another scientist, Johannes Hevelius from Gdańsk, known for his works on comets and the moon. We can actually mention many observers and scientists, but it's worth to actually follow Oberster-Leutnant Kazimierz Siemianowicz, who wrote an artillery textbooks where he discussed the technology of producing multi-stage rockets. Well, this textbook was the basis for education for the next 200 years, and the construction that was the first satellite launched in 20th century, Explorer 1 and Sputnik 1, were consistent with his idea that he presented 300 years before that. I seem to have some technological problems. Also, the ideas mentioned by Konstanty Tsiolkovsky, who was a Russian scientist with Polish origins, were the basis of the activity of all historic and contemporary engines of the rockets and spaceships. So Russian with Polish origins. Well, that was historic, for historic reasons. At that time, Poland was under partitions, and that's why Russian. And Tsiolkovsky was convinced that his dream, theoretically justified, will become reality, and many people will witness the first journey outside of Earth's atmosphere field. Ari Sternfeld, one of the pioneers of the space industries, a Polish person with a Jewish background, called the navigator of space routes. He was calculating the orbits of satellites, of celestial bodies. In 1932, he wrote Initiation to à la Cosmétique, and that was presented during the meeting of the Polish Association of Friends of Space in the Astronomy Center of Polish Warsaw University. But that was nothing interesting for people at that time, which was a big disappointment. So he went back to Paris, and this is where he received an International Astronomic Award, and he continued his work in the Soviet Union, where he became the creator of Russian space journeys, and he is called the father of the space industry there. And he introduced into our this dictionary the Polish word kosmonauta. And the achievements of the past years, decades, include the beginning of exploration of the solar system through the space technologies, and that was the real novelty. The Soviet space program, Interkosmos, was Polish first steps into the space exploration. So pilot Mirosław Hermaszewski, the general, in 1978, he became the first Polish cosmonaut pilot and, well, that was also the time when the Polish Center for Space Research in the Polish Academy of Sciences was launched. In 1970, on the 28th of November, the young Dr. Zbigniew Gordelewski, with his assistants, he presented the structure of the X-ray heliograph, the first Polish space instrument launched into the space. Later on, it was a time of a lot of challenges, not just technological, but also mental, from different circles. The need to focus on this part of science was not understood by the decision makers. Luckily, after 45 years, we can say that Poland is actively participating in exploration of space. During the first years of CBK's activity, we painstakingly proved our presence, our existence, also to those circles, scientific circles, who cooperate tightly with us right now. Whereas the society understood how important this is later on, actually convincing the politicians to our activities helped us to develop. The support from the parliamentary space group was a turning point in perceiving the space and how greatly it affects the civilization right now. And the past 10 years of our tight cooperation with European Space Agency showed us how important the space is for the economic development of the country, that it may become a driver for innovation among many companies and science. Science is something that gives us answers to our curiosity, but only the constructive application of the scientific inventions means the use, digestion of the fruits of science. Well, this is actually part of the scenario of scientific and applied use of science. So not only scientific uses, but also use in everyday life. We are able to plan an experiment, conduct it, and follow it with the help of rockets and instruments. Advanced instruments appeared. They are more detailed, see better, and show us better, and they can be used in everyday navigation, robotics, and many more domains. But first of all, in the practical lives of companies and administration or people. As we know, the science has always inspired the development of technology, creating effective steps and activities. I have two examples of that. Two examples of experiments that were conducted by Center for Space Research with freshly launched still small, but commercial institutions, companies. And here we have a space observatory Herschel that was effectively repaired on the orbit, and spacecraft Rosetta. The flight to Comet, Rosienko, going through Earth, observing two asteroids and researching its surface and atmosphere. And these are the missions that are right now taking place. Solar Orbiter, observation of the Sun crown and the solar wind. This is a fresh mission, but the instrument called STIX was constructed in Poland, and it gives us great and very promising observations. We also have the Cassis here. This is another example. It actually probes the atmosphere and surface of Mars, and we have examples of future missions that are being prepared right now by the institutes and companies, young companies.
okrzepu w swoich
that
zadaniach kosmicznych.
right now know very well what are the
Przyszłe misje,
space
a więc
tasks.
Comet Interceptor.
So Comet Interceptor,
Czeka na nową
a
kometę
satellite
wychodzi
that is
słoneczną.
waiting for a new comet in solar system that will come nearby, and following the comet will give us great conditions for observations. Ariel Cosmic Telescope to probe around 1,000 atmospheres of planets outside of solar system. Peer Space, an instrument to capture dangerous objects on the orbit of Earth. Right now we have around 5,000 working objects that are on the orbit of Earth. Over 3,000 of them are, should not be there. They are an obstacle, not mentioning those objects that we don't know. Or we should actually launch them outside, beyond the orbit. There is also JUICE, so it's a mission to 3 ice moons of and this is a great mission where we are very happy to be participating in it, because this mission and these are tests of new technologies, and this is how we are sure that the development of the space technology and science in Poland, also because of our cooperation with ESA, showed us a tangible, visible growth. And we also hope that the Center for Space Research of the Polish Academy of Sciences help to do this.
Bardzo dziękuję pani profesor za
Thank you,
przybliżenie
professor,
historii polskiej
for
eksploracji kosmosu. W
telling
ciągu
us
minionej
about
dekady
the
polski
Poland
sektor
space
kosmiczny
exploration.
zmienił się
During
w
the last
sposób
decade, the
bardzo
Polish space
znaczny.
sector
O szczegółach
changed
tej
very
zmiany
considerably.
opowie
The details
przewodniczący polskiej
will be
delegacji do
given
ESA,
by the
pan
head
Piotr
of the
Zabadała.
Polish
Zapraszam.
ESA delegation, Piotr Zabadała.
Dzień dobry Państwu.
Good morning, ladies and gentlemen.
Szanowni Państwo, spotkaliśmy
Ladies
się
and
dzisiaj
gentlemen, we are
tutaj,
meeting
żeby
here today
świętować
to celebrate
dziesięciolecie Polski WESA
10
i to
years
będziemy
of
mieć wszystkie przypadki.
Polish membership
Ale
at
zanim na
ESA.
scenie pojawią się
But
eksperci,
before
zanim na scenie pojawią się
we
kolejni
invite
paneliści,
experts to the stage and the
członkowie
panelists,
ESY,
members of
eksperci,
ESA,
chciałbym się
experts,
podzielić
I want
z
to
Państwem
share with you
kilkoma informacjami,
some
co się
information
wydarzyło w tym dla nas
on what
magicznym
happened
2012
in the
roku.
magical
Nie wiem, czy Państwo
2012.
pamiętacie,
I don't know
ale
if you
13
remember,
marca
but on the
2012
13th
roku,
of March
po
2012,
246
after
latach,
246
zaprzestano
years,
druku Encyklopedii Britannica.
the Encyclopedia
bardzo
Britannica
duże,
stopped being
wyzwanie.
printed. This was a very big
17
challenge.
marca,
On the
czyli kilka dni
17th of
później,
March,
zakończyła
a
się
few days
misja
later,
amerykańskiej sondy
the American
Messenger,
mission of the
która badała
Messenger
Merkurego.
probe was completed.
15 kwietnia
On the
obchodziliśmy
15th
setną
of
rocznicę,
April, we celebrated the
setną rocznicę
10th
katastrofy
anniversary
transatlantyku
of the
Titanic.
Titanic disaster.
Natomiast miesiąc później,
And a month
25
later,
lutego,
on the
podczas
25th
drugiego
of
już
February,
roku,
on the second test
statek,
flight,
Dragon, jako
the
pierwszy w
Dragon,
historii
as
komercyjny
the
statek
first
kosmiczny,
commercial
przycumował
space
do
ship,
Międzynarodowej Stacji
arrived
Kosmicznej.
at the International
8
Space
czerwca,
Station. On
bardzo
the
niedaleko
8th
stąd, za Wisłą,
June,
rozpoczęły
close
się
to
europejskie
here,
mistrzostwa w
the
piłce nożnej
European
Euro
Football
2012.
Championships
Meczu
Euro
inauguracyjnym
2012
w
started.
Warszawie
The opening
Polska
match
zremisowała z
in
Grecją.
Warsaw, it was Poland
No,
and
a
Greece,
mistrzostwo wygrała jak
ended
zwykle
with a
Hiszpania.
draw, and the championship as
Kilka
usual
dni
was
później,
won by Spain.
rozpoczęła się
Several days later, the Chinese Shenzhou 9 mission began with the first Chinese female astronaut on board, and in July, the Statistics Poland published the results of the census, which demonstrated that there are 38,511,824 Poles. That's quite a lot of people for a member states of ESA. In June, CERN announced the registration of a particle similar to Higgs boson, and then the rover landed on Mars. In August, Voyager 1, first man-made probe, exceeded Heliopause and found itself in the interstellar space. Then the Hubble telescope discovered the galaxy MACS 1149 JD, 13.2 billion light years from a year. And in December, on the 21st, the cycle of the Mayan calendar ended, the end of the world, according to some, and according to some supporters of esoteric theories, this was to be the moment of the great spiritual transformation of humanity. And in this atmosphere, in 2012, so important to Poland, began its accession to ESA in July 2012. The ESA Council unanimously approved the Polish membership. In September, there was an exchange of documents from the Polish side conducted by the then Deputy Prime Minister and Minister of Economy, Waldemar Pawlak, and at the side of ESA, the then General Director Jean-Jacques Dordain. In November, the Parliament, the Senate and the President of Poland ratified the accession treaty. This way, Poland became the 20th member of ESA, 20th member state of the European Space Agency. With Poland's accession to ESA, the Polish Industry Incentive Scheme was launched. So the acronym is PLEASE, which opened the doors to ESA to Polish entrepreneurs. It allowed them to learn about the specific character of ESA, the standards, the administrative procedure. It enabled them to meet the experts from ESA. It enabled contacts with the entities of the European space market. It enabled the development of the selected skills and technological solutions and the accomplishment in them a level that made it possible to compete in ESA's tenders. The program was to last 5 years, but on the 12th January 2017, the Deputy Prime Minister, Mateusz Morawiecki, was and now the Prime Minister, who used to be the Minister of Development, and Jan Werner, the then General Director, signed an agreement extending PLEASE until the 31st December 2019. From what I know, this was in the history of ESA, this was the first approval like that to extend the transition period. Ladies and gentlemen, Poland's accession to ESA is undoubtedly a great Copernican transformation for the Polish industry. In 2012, there were around 30 companies, and now there are around 400 companies operating in the space sector. Poland's accession to ESA enabled Poland's participation in ESA's programs, which was already mentioned. It enabled access to ESA's research infrastructure, to access to training, access to internships, and enabled the participation in in optional programs. Today, Poland is participating in 10 such programs, and this is an exceptional moment because in a month we will be declaring another presence in this section of ESA's activity. As a result of Poland's membership in ESA and as a result of the contracts which were concluded by Polish companies, thanks to that, a new sector of the economy in Poland was created, the space sector. This is still a very young sector. A big majority are SMEs, and the area of their specializations are as follows. We could identify solutions for robotics, optical solutions, the development of material technologies, composite technologies, rocket technologies, avionics, precision mechanics, and many other. Like I said, there are around 400 entities on the market registered at ESA. 400 entities, almost 80 of them are companies, 20 are research and development agencies, institutes, universities. The universities and research institutes with a lot of experience, like Madam Professor Stanisławska showed us in space exploration. The space sector from the beginning of its history was something that drove the development of innovative technologies. It is also a great example of the practical implementation of these technologies. ESA membership stimulates close cooperation between science, which, as has been said, has experience, and enterprises which can implement these solutions in practice. The advantages of space technologies are used and noticed by sectors like aviation, the defense sector, or motoring or automotive.
But those achievements are also applied in other domains such as banking, zoning, connectivity, crisis management, safety and security, and many others. We all use mobile phones that were created with the help of such technologies. So the year 2012 was a very important year for Poland's joining active exploration and use of space. Well, we had the first students' nanosatellite launched into the orbit, Nanosat, then LEM, Hevelius, and then right now the challenges that we face in Poland are the new projects that are being prepared. In recent years, Polish technological thought and Polish engineers and scientists and researchers participated in many missions, Huygens, Rosetta, Epicolombo, and many others. Today we are in the Ministry of Development and Technology, a ministry that perceives this sector as a highly technological industry that may contribute and contributes to economy based on knowledge, innovative economy. But in this building, exactly, since the very beginning, this is where Polish ESA's heart has been beating. In this building, 3 floors above us, Polish delegation to the European Space Agency is coordinated. In this building, we have the head of Polish delegation, Otylia Trzaskowska-Newell. I'd like to thank her for her presence today through Ania Nużycka, who you all know, Robert Nowicki,
Ja dzisiaj
until
siedzę
today,
cały czas przy tym samym biurku, w tym samym
Otylia,
biurze, w
I'm
którym ty
still
siedzisz.
sitting at the same desk
To
at
właśnie
which
w
you were
Ministerstwie
sitting.
Rozwoju i
Here in the
Technologii
Ministry
podejmowane
of
są
Development and
najważniejsze dla państwa
Technology,
decyzje
the most important
dotyczące
decisions
udziału
are
kosztów
taken for you,
kolejnych misji.
and they
To
relate
właśnie
to
w tym
Poland's
budynku dzielony
participation
jest,
in new missions. In
budżet,
this
który
building, we
naprawdę
divide the
najbardziej
budget,
portfelem wszystkich interesów.
which is the most interesting
Ale,
element for all of you, I'm sure.
nic nie jest możliwe
But
bez
of course,
współpracy.
nothing could be
I
done
my
without
mamy to wielkie
cooperation,
szczęście,
and
że
we
mamy
have
możliwość
this
współpracowania z
great
wieloma instytucjami.
luck to cooperate with
Ministerstwem
many
Edukacji i
institutions.
Nauki,
Among
między innymi
others, this is
Ministerstwem
the
Obrony
Ministry of
Narodowej,
Education and Science and Ministry
Kancelarią
of
Prezesa Rady Ministrów
National
Krajowej
Defense
Cyfryzacji
and the
Gospodarki
Office
Polskiej,
of the Prime
Ministerstwem
Minister,
Spraw Wewnętrznych,
the Ministry
Centrum
of
Badań
Interior,
Kosmicznych, Polską Agencją
Space
Kosmiczną,
Research
wielu
Center and
innymi
Polish
instytucjami,
Space
które nie
Agency,
jestem w stanie,
and
nawet
many
wymienić.
other institutions which I'm unable to list today. We also cooperate with the Association of Employers in Space Sectors, and they are also celebrating their 10th anniversary today. And without them, the space industry would not develop in Poland. Ladies and gentlemen, I would like to thank on this occasion of the 10-year anniversary, I'd like to thank everyone who contributed to Polish delegation to ISA, to the potential that we can share with and be proud of today. I like to apologize because I'm unable to name all the people, all the names, all the delegates who participated in Polish delegation throughout those 10 years, but also those who before this 2012 participated in our efforts. I'd like to tell you that they also did it on the magical third floor in the same building that in which we are today. This is the celebration of all of us, and I'd like to also thank for our colleagues from ISA who joined us in this celebration, and I hope that we will have many opportunities today to learn about the successes, about what we were able to complete, and what may happen in the future, hopefully what are the plans of Polish Space Agency. So thank you very much, ladies and gentlemen. Please stay in touch with us. We are ready to take part in any meeting. Thank you very much.
Bardzo dziękuję.
Thank you very much for this historic return to 2012 and the historic overview of the most important events in the past 10 years. Ladies and gentlemen, the changes in the space sector after joining ISA are most felt by the interested parties. That's why I'd like to invite Paweł Wojtkiewicz, the head of the Association of the Space Sector Employers. Ladies and gentlemen, Madam Professor has summarized 500 years of Polish exploration of space in few minutes, and the director told us about the past 10 years in few minutes, and I will also tell you about the 10 years of our association of the space sector employers. Please forgive me if there are any omissions, but definitely 10 years of our association of Space Sector Employers. I will try to tell you about the history, about what happened, underlining certain elements, which according to me are a great summary of the past 10 years. First of all, integration. I will not be talking about the integration of the structures of the satellites because we have specialists here. I will tell you about the integration of the companies, of the circles, of the people in this. So first of all, we had the economic self-government, and the main goal was the full membership in ISA. And presentation of the first recommendation of for Polish delegation to the Ministerial Council. And the first space exhibition in Polish Parliament, well, I found some historic photographs, as you can see here. Well, this exhibition was very successful, and that is mostly due to Polish Parliament at the time, because they wanted to talk to the space sector, and we had this opportunity to present the space sector in the Parliament, and a photograph of when the association was launched, 19 entities, representatives, and right now this is the research network, and it happened in the Institute of Automation, and it was a very important place, an incubator of this, and this reminds me Andrew Smith, who wrote that Apollo program was built by people who had no idea how to land on the moon, and in 2012 we were building the space sector without knowing exactly which path to take, but we had mentors, just like Apollo program creators, because we had great bases, scientific foundations, also from the Center for Space Research, cooperation. This is the best slide to show it. Well, these are the logos of all entities who are working now in the space industry. As the director and Madam Director and the Professor and Madam Minister said it before, well, we've been creators, we've been contributing to the new industry. Well, space industry, as it was said, just several dozens of entities, companies. These are all SMEs, big companies, research institutions, and branches of international companies. Well, this is a big mixture. This is the Polish sector, space sectors right now. Numbers. Well, we are entrepreneurs, so we like numbers, and all present here in the room are always interested in what the space sector offers to Poland, how it changes and how it functions. Well, the first number that we found, I'm sure it's bigger right now. Since 1977, we had 77 different missions that used the technologies, products and services created here in Poland. Well, in my opinion, during the dozens of years that passed, this means quite a lot. And since 2012, this process has accelerated. In many missions completed by ESA today, Polish entities, Polish companies participate. This is the number of the members of our association, showing you how dynamic the development was. Right now, as you can see, we have several companies, but also some are outside of the association. There are universities that focus on the space. So the number of entities interested in space is bigger, and the number of entities that link their business future with space is a little bit smaller. And the number of people hired by the companies associated in our association. Well, right now the numbers aren't very impressive, but right now in the companies, in the universities, we have 6,000 employees, people who are connected with space. In those companies, the number of those people is even is a bit smaller, but that also shows you the scale. What is the potential, the capacity of the companies interested in space sector? More numbers and data. Well, geographical distribution. I believe that this is a very interesting slide. The biggest part, the orange one, means Mazowieckie Voivodeship 10 years ago, and right now we have many companies, and the biggest number of companies interested in space are located in Mazowieckie region. But as you can see, more dots appeared in the past 10 years. Well, that's good, because because that shows us that this sector has developed since our membership in ESA, and in many other regions there are companies who are interested in space. More numbers and riddle. You can actually do it privately. There is no prize for that, no award for that, but I wanted to show you the example of several companies to show you how they developed. There is this downstream company that joined our association in 2015. They declared 8 employees, now 160. A company that is strictly focusing on space, from 3 to 75 employees. Upstream company, but producing electronic components, 3 employees declared in 2012. And right now, it's over 150 employees. Space Safety, another company. We can see that in this space activity area, the business can develop. So upstream, downstream company, I cannot actually, I didn't want to distinguish any certain company, but I just wanted to show you the data to prove that the investment such as the focus on space and our membership in ESA can be something profitable, because these are all employees who are highly qualified and they work in high technologies, and Polish industry needs those employees the most. So greetings from Poland. So as a main, one of the main objectives in addition to ESA membership, well, we wanted to promote Polish space sector in Poland and abroad. All the aspects were very important. Therefore, we organized many exhibitions. We had many study tours and tours with PARP, Polish Space Agency, with the ministries, organization, which is the most important in the context of ESA. We did a lot actually. In 2013, I found some data. We had we visited 6 different countries with Polish delegation of companies and universities, institutions. That proves our involvement, our dedication. Well, many people in the room today wanted to create those journeys, to prepare them well, to present the services and products.
So Director Zabadała mentioned that a lot of companies from the space sector are SMEs. So this is true. And the contracts. We all thought that, well, space, this is like a golden business, and many companies wanted to embark on this adventure in the space sector. And we, as the association and as institutes, companies, we wanted to provide as much information about the space sector as possible to the decision makers, to the administration, because the life of our companies largely depends on the decisions of the administration, of the delegations. So since 2012, the firms, the associations of the association inform about the functioning of the space sector. We developed recommendations for the national space program. Whenever the ESA Ministerial Council takes place, this information is presented about the needs of the space sector. We developed, we contributed to the Polish space strategy. We are implementing a number of projects, and for our ESA guests, I can say we are part of the consortium implementing ESA team. The second part of the project of acceleration the activities in the space sector. We know that another contract will be signed at ESA Big tomorrow, ESA team is the second pillar of this activity. The Association of the Space Sector Employers also needs to be mentioned here, a range of other projects implemented with ESA funds, with the funds of the European Commission to speed up the development of the space sector in Poland. Communication, another word which keeps recurring when talking about the activities of companies and the activities of the Association of the Polish of the Space Sector Employers. So the main goal is the promotion of the industry. The first conference, it was in October in the Parliament. There was a lot of interest, and then a range of other conferences which I cannot count. I don't have this possibility, so I am just listing the biggest ones which we managed to organize as the association, of course, with the involvement of ministries and the agency. 3 editions, over 800 participants in total. We are active. We are active in terms of communication, both communication with the media and communication with the administration. Over 400 official letters and announcements were produced during these years. So we are working very hard to contribute to the development of the space sector in Poland. And I mean here all the entities involved in providing the key information that is shared with the ministries. So to sum up, integration, cooperation, promotion, contracts, numbers and communication. For me, these words are an excellent summary of this decade, and I believe that if we keep acting based on these words, the Polish space sector will continue developing very well. I encourage all of you to stay for the industry panel. I think this will be a successful discussion on the space sector in Poland in that decade, what it was, what it is, and what it can be. So I'd like to invite you to the panel because during the panel you can see and you can listen to many representatives of companies and institutes operating in the space sector. Thank you very much, and again I wish you a fruitful conference. Thank you. Thank you very much, President, for presenting this full summary. The changes in the Polish space sector from the perspective of the European Space Agency will be discussed by the Director of ESA for European Legal and International Matters, Mr. Eric Morel de Westgaver. Let me invite you to the stage, Director.
Good morning. It's a real pleasure to be here in this building. For me, it's a lot of souvenirs. This is where we have negotiated the accession of Poland to ESA. I remember the meeting rooms. I've been also very frequently for the implementation of the industry incentive scheme that has been mentioned. And so this is a building that I know very well. So already we have, several of the speakers have mentioned the 3 main steps. First, the agreement, then the PECs, and finally the adhesion to ESA. What was not said is, I think, the world record of Poland, because as was said, you have seen the picture, the signature of the agreement here in Poland was on the 13th of September 2012. But then the ratification has taken place, and this ratification went at the speed of light, which for space is quite normal, and I think you have established the world record of ESA member states between the signature and the ratification. And also your Ministry of Foreign Affairs has been extremely efficient. You have sent a special courier to Paris to bring this agreement signed by the President and allowing the Polish delegation to enter into the ministerial meeting in Naples the day after as full member of ESA, and therefore able to subscribe to all the programs that were presented at that occasion. So you see from PECS to full membership, you see the evolution, the number of projects that we have placed, a growing number of activities, but also the possibility to move from a collaboration and to entering progressively into the full life of the agency when joining. So when we look at the period of PECS, we have placed in your country contracts for some 12 million euros during this period of 7 years, and we have covered mainly Earth observation, navigation, space technologies, of course, but also exploration, the education, and many technological aspects. This has progressively built in Poland the basis that was justifying your adhesion to ESA. That, as I just remember, happened in 2012. So from there onwards, we have implemented what was called I'll go too fast. There we are. What was called the Polish Industry Incentive Scheme, which was a scheme that has been put in place, allowing a direct contact between ESA and the Polish companies, replying to announcement of opportunities, and therefore progressively joining more and more the ESA project. Here you have the first signature of those, the first set of contracts that we have placed, less than 1 year after your adhesion. That has taken place in this building, and the contract was signed by industry and by ESA. That was the first round of contract that we have signed. But what were the achievements of this industry scheme for Poland? What have we done? 75% of the contracts that were placed were related to upstream, were related to space equipments, including a ground segment. 25% were more devoted to downstream applications, and 70% of the contract were related to generic technologies that can be used in more than one mission, and therefore that can be used far more in the ESA context. The relation between academia and industry, and I think it's important for the Polish Industrial Association, has increased progressively. We were with 60% in industry in 2012 when you joined ESA. Today we are with 85% in industry and 15% in academia. So you see very well the evolution of this scheme and the increased role and importance of industry. What are the main capabilities that we have created in Poland? Structure, harnesses, propulsion, mechanism, robotics, radio frequency, navigation, electronics, software and downstream, space situational awareness. Nearly all the domains of space activities, you can find Polish industry and academia being present. Now, let me give you a global overview of the evolution. You see, during the PECS period, the first 7 years, 52 projects, 12 million. You see the Polish industry incentive scheme as really we moved in another dimension with 204 projects, 52 million during a shorter period. So you see this enormous increase. And when you look at the overall activities, we have placed contract with more than 200 entities in Poland, more than 500 contracts for more than 200 millions in Poland. And important, I think, to underline, 40% of those contracts were placed with small and medium enterprises. I think this is a percentage that is among the highest in Europe. The contribution of Poland at the two last ministerial meetings, you see 45 million for optional program, then 40 million, and for the mandatory activities in the range of 80 million. And the domains into which Poland has contributed to ESA is mainly in technology, but also Earth observation and science, navigation. You see all the domains that are, of course, linked to the contribution of Poland to ESA. But let's go to a few, I would call success stories in Poland. Aluminium, carbon composite spacecraft panels that have been used on Copernicus, on commercial telecom satellites. Spacecraft radio frequency units that passive and active that are now work that you do with most of the international companies active in telecommunication satellite. Spacecraft mechanism, you have worked on JUICE, the deployment booms and the antenna. You have also been active, and this was said a few minutes ago in Proba 3. You see those mechanisms that have been produced also for ExoMar. So this is becoming an activity in Poland where really we see a specialization. I would take three other examples. Production of flight harnesses. You have done that for a number of ESA satellites, but also artificial intelligence that are used in Poland for image processing. And I'm sure we'll speak about that more this afternoon about Earth observation, but also analysis of satellite radar imagery, allowing ship detection, ground deformation monitoring, for example. All those are activities and I think real success of Poland. Now let's go to a few capabilities that have been created. Application, cloud-based services in the Copernicus data platform. I think this is something important, and important for today, but really important for the future. Also, and that is quite important, in the first Earth observation satellite produced by ESA with artificial intelligence, you see there the role of Poland really at the forefront of the evolution of technology in this domain of Earth observation. Now, let's have a look at the footprint of Poland in ESA and of ESA. European Space Resource Office in the Copernicus Space Science Center here in Warsaw. We have, and this was, remember a minute ago, the ESA technology brokers, business application ambassadors, and also the ESA lab that has been established at the Kosmicki University and at the Gdańsk University of Technology. And tomorrow?
The first objective is to in orbit around our home planet Earth, the International Space Independence. Shouldn't we find a way to get there ourselves? What if Europe were to develop its own crewed transport system? The Space Rider demonstrator is a step in that direction. Striking out beyond the moon, we'll send the Sample Fetch rover to Mars to collect samples and bring them back to Earth, so scientists can unravel the mysteries of the Red Planet. Many other missions will be key to prepare for human exploration of our sister planet. Let's take part in those first steps. And why stop there? There's a natural satellite around Saturn named Enceladus, which may also harbor life. Isn't life the very essence of our planet? Together, let's explore space, traveling farther so as to come back with new knowledge to improve life on Earth.
Technologie kosmiczne wspierają nas w codziennym życiu. Dzięki obserwacjom satelitarnym możemy prognozować plony, przewidywać skalę powodzi, zasięg pożaru, a nawet monitorować stan naszej planety.
Brzmi kosmicznie? Sprawdź to!
Czy wiesz, że technologie kosmiczne pomagają nam dbać o zdrowie? Skanery medyczne, odporne na zarysowania szkło wykorzystywane w okularach, czy laserowa operacja oka? To tylko niektóre z przykładów.
Brzmi kosmicznie? Sprawdź to!
Technologie rozwijane przez sektor kosmiczny to nieodległa galaktyka. Obserwacje satelitarne mają bezpośredni wpływ na nasze bezpieczeństwo. Wspierają ratowników medycznych w niesieniu pomocy.
Brzmi kosmicznie? Sprawdź to.
Houston, Tranquility Base here. The Eagle has landed.
It's 60 years since humans first went into space. By using rockets and developing life support systems, we have learned to live and work in orbit around our planet. But we dream of exploring farther, to set up home on the moon and beyond. ESA selects astronauts from our member states to train for and complete our missions. To be an astronaut, you must be experienced in technical work and healthy enough to fly to space safely. Once selected, astronauts try to fly in space and to conduct a whole range of experiments there. Our astronauts train with partners agencies around the world, and particularly at ESA's Astronaut Center in Cologne, Germany. ESA conducts special studies on the ground to prepare for missions in space. Our home planet has extreme environments where we can train astronauts and test equipment. We work underground, in volcanic landscapes, and in isolation in the Antarctic. We test tools in rocky landscapes and create and store materials that resemble the surface of other planets. We also create elements of the space environment. We use bed rest and parabolic flight to test the effects of weightlessness, as well as Mars yards and lunar bases made with simulant dust. The International Space Station is one of the most amazing machines ever built. A huge international team worked together to make a laboratory where astronauts can run experiments to help life on Earth and our future lives in space. As well as doing their daily experiments, astronauts on the station need to be able to monitor their health and well-being and support their fellow crew members. They communicate with the ground regularly, including with flight controllers based in Europe. Some experiments and repair work on the space station require astronauts to go outside. They wear spacesuits to conduct extravehicular activity, also known as spacewalks. Spacewalks are rehearsed in detail, using deep swimming pools to simulate the weightless environment. Spacesuits are brilliant machines, like small spacecrafts in themselves. But we would like to make them smaller and easier to move around in, especially for walking on the Moon and Mars.
Szanowni Państwo,
Ladies and gentlemen, we would like to welcome you after the break. This is still the first day of our conference, 10 years of Poland's membership in ESA. Yesterday, today, tomorrow, organized by the Ministry of Technology, Polish Space Agency and the Association of the Employers in Space Sector. We are starting the panel connected with the development of the Polish space sector. And first, the Vice President of Polish Space Agency, Michał Wierciński, will tell us about those elements that we are proud of. Well, good morning, ladies and gentlemen. I would like to start with apologizing everyone whose logos will not be presented here, as well as the projects that will not be mentioned today. Unfortunately, we have time constraints, and as we told you, our sector has developed greatly throughout the past years. Well, we will be focusing on the past 10 years, and the element of that time is our membership in the ESA. And this will be just the foundation for the panel, which will be the conversation with the representatives of Polish companies. So now, very briefly, what did we achieve? What are we proud of? As it was heard today, well, we were actually able to build Polish companies. As we said, we have around 400 companies registered in ESA, but around 60 of them spare no efforts on space projects. These are mostly SMEs, around 80% of them. Those that do a lot in this industry, they hire 1,500 engineers. After 10 years in ESA, we were able to complete 500 projects worth 115 million euro. They came back to Poland. This is the money that came back to Poland as part of the signed contracts. Well, we started with components, then the subsystems. Then, right now, after 10 years in many fields, we are able to be the leader of the project. What else? We created the Polish platform of the satellite platform, Eagle Eye, and this is a unique project in this part of Europe. Central and Eastern Europe has no this kind of solutions. This is the effort of around 10 companies and entities. 75% of the subsystems of the satellite come from Poland. They were designed and produced in Poland. Then we will have a test case, which will happen in autumn 2023, and later on the satellite will be launched into space. Well, then we were also able to create one of the biggest repository of the data from the satellite imaging. Well, it comes, this is 31 petabyte of data. This is as much as 62,000 laptops. This is what they contain. So in this repository, we have 12,000 users registered, 4,000 from Poland. Every day, several terabytes are, 115 terabytes are downloaded for agriculture, cartography, and so on. What you can see here on this slide is an example of imagining, so Sentinel and imagining what the president of ESA has said, how the satellite data can be used by different industries. In this case, we are talking about in agriculture. This shows the status of forests around Łódź and the gradation of certain insects that. And what else did we do? We are in the space security and safety area. We have the leading role in following what is happening over our heads. We are member of the USSD consortium. There are 12 telescopes located around the world. We are the third contributor in the EU as part of this consortium, so provision of data from the observation of the space. 10 years of Poland's membership mean also nanosatellites. Today we have exactly 10 pieces of nanosatellites, 2 scientific, 8 commercial. We had even more of them a few years ago. The student ones, so Traksat from agricultural, from the mining and technology university from Krakow. This year there will be more launchings. And 10 years, the past 10 years mean construction of Polish technical competences in the launching systems, in rocket systems. Well, first we had the Meteor system that actually was stopped in the 1970s, and then the competences, skills here started to degrade. But during the first 10 years since the first decade of the 21st century, we started to really improve and recreate those skills. Technologically, we are able to do this, but the only limit, restriction that we have today is the accessibility to the launching platforms, and it is actually not possible from Poland. 10 years will also mean dynamically educated personnel in Poland. Well, today, in Polish technological universities, we have around 20 departments, 20 majors, educating 3,700 students. And every year, a Polish university bring around 800 graduates to Polish industry. So this is a huge potential here. That is a feature of our industry here. Let me tell you this. I'll tell you 2 things. I believe, and I believe that everyone will agree with me, but this sector wouldn't exist today, and you wouldn't have the skills that you have today if not Poland's membership in the European Space Agency. But I also think that our achievements today and your skills and capacities today is also the contribution of the Space Research Center that has been developing the skills in designing, delivery of instruments. And in the past, especially in the past 10 years, we were able to join the super class of scientists and designers when it comes to actually instruments. And this is the example, the Solar mission, Solar Orbiter, a project of ESA and NASA together, and we were actually responsible for an instrument. This is not the graphics, this is the real picture that that was made by this probe. And the Space Center, Space Research Center, well, it's a very important place because many of you started their careers there. And this means also very ambitious future projects mentioned by Madam Professor. So Ariel mission, so searching for life outside, beyond the solar system. There is a probe that will be launched in 2029 to do so. So in the very end, I'd like to thank Madam Professor for the support for the Polish sector and this huge effort that was given to educating the personnel, the staff. That's all from me because we have limited time, so I'd like to give the floor to my colleague. Thank you.
Bardzo dziękuję pani
Thank
prezesie
you
za
very
przedstawienie
much,
powodów
President,
do dumy
for
związanych z rozwojem polskiego sektora kosmicznego po
showing us
przystąpieniu
the
do
reason to be
ESA.
proud
Szanowni Państwo,
after
kontynuując ten temat,
Poland's
zapraszam
accession to
na
ESA. To
nietypową
continue on this
podróż
topic,
po
I'd like to
podmiotach
invite you
polskiego
on
sektora kosmicznego. W tę podróż
an
zabierze
unusual
nas prezes globalnej
journey
sieci Space Communications
across
i
the
znany
entities.
Space Communications Alliance oraz
Space
założyciel
Communications,
partner
Space
znany
Communication
części z Państwa
Alliance,
bardzo dobrze, Łukasz
founder of
Wilczyński.
Planet Partner, Łukasz Wilczyński.
Włączyłem. O, teraz pięknie. Szanowni Państwo, ja może
Ladies and
zacznę od tego
gentlemen,
2012
I will
roku,
start
dlatego
with
że to był bardzo
2012
nietypowy
because
rok,
this was a
nie tylko w
very
sektorze
unusual
kosmicznym.
year.
Ja
Not
chciałem
just in the
przypomnieć, że na
space
ten rok
sector. Let me remind you
starożytni Majowie
that,
zaplanowali koniec
that
świata.
for that year, the
I tak to było z
Maya
tym kryzysem z
planned the end of
2008.
the
Polska
world,
postanowiła nie brać w tym udziału
like
i
with the
postanowiła
crisis of
wstąpić do Europejskiej Agencji
2008, Poland
Kosmicznej.
decided not to
My z moim zespołem
participate, but to
prześledziliśmy
join
też
ESA.
nagłówki,
With
które
my
wtedy były. To
team,
była fajna podróż, żeby
we
prześledzić
looked
nagłówki,
at
o
some
czym pisały
headlines
media w
from that
2012
time
roku właśnie w kontekście sektora kosmicznego. Dużo uwagi zabrało lądowanie Curiosity na Marsie z polskimi urządzeniami na pokładzie. Dużo mówiono też o pierwszym dokowaniu komercyjnym Dragona do ISS i o wyruszeniu sondy Voyager 1 w podróż międzygwiezdną i oczywiście ESA, wstąpienie Polski do ESA. Tutaj publikacje, jakie prześledziliśmy, właściwie były jednogłośne. Jednogłośnie wszyscy podkreślali, że wstąpienie Polski do Europejskiej Agencji Kosmicznej przyniesie szereg korzyści technologicznych, ekonomicznych, naukowych, edukacyjnych. I przypomnę też słowa ówczesnego dyrektora ESA, który podczas ceremonii podpisania traktatu akcesyjnego powiedział, że ESA przyjmując do swojego grona 20 państwo wkracza w dorosłość. I właśnie o tej dorosłości technologicznej chcielibyśmy dzisiaj porozmawiać, o tym, co udało nam się dokonać w polskim sektorze kosmicznym z perspektywy podmiotów sektora kosmicznego. Zacznijmy od aplikacji i przetwarzania danych satelitarnych i na scenę zapraszam panią Monikę Krzyżanowską z Cloudflare, pana Witolda Fedorowicza-Jackowskiego z Geosystems oraz pana Jakuba Ryzenko z Centrum Informacji Kryzysowej.
With the Crisis Information Center of the Polish Academy of Sciences.
Proszę bardzo.
Over to you.
Panie Witoldzie, pierwsze pytanie do pana.
Witold, first question
Mamy 10 lat Polski w ESA. Kiedy pana zdaniem polskie podmioty, szczególnie te prywatne, zaczęły świadczyć usługi w oparciu o zobrazowanie satelitarne i jakie to miało znaczenie dla przystąpienia Polski do ESA?
Dziękuję za pytanie, dziękuję za zaproszenie.
Thank you very much. I will give a precise answer. Poland's entities, private entities, appeared after the political system transformation in 1989-1990. They were based on a very long tradition where what we called Earth observation or geographical imaging was applied in Poland. Back in the 1960s, at many universities and many institutes, mainly the Institute of Land Surveying and Cartography in Poland, we had the specific chamber that educated chair that educated people, and there was the decision 14575. In 1975, the government decided to create an ultra-modern center for the processing of such data called Opolis. In the room we have Professor Dąbrowska-Zielińska, who is still the head of the center. It has a different name now, but it was a fantastic adventure for many young people who were entering maturity then. They sent us to the east and to the west. We cooperated with the Americans, with the Soviet Union, with Europe. We went on internships, so we could spend like half a year at Flagstaff, and the staff was growing. We had equipment back then that was interesting. There was an embargo in force, so it was, I don't want to say smuggled in, but it was somehow obtained. There were great people back in that epoch. Director Bogdan May, one of the youngest directors in history of the Polish institutes, knew how to navigate this area, maybe because his brother was a member of the Central Committee Bureau, but Opolis operated for many years, and it was like a place where many excellent minds originated. I can see General Hermaszewski in the room, and that's how it all started. After the transformation, different joint ventures companies were established, including IT companies. I'd like to extend my thanks to the current director of the Space Research Center, because at Space Research Centers, in the basement actually, in one room, back in 1995, I started my company, and there were a few companies like that later on, which grew, and they performed different actions. In the 1980s, we prepared maps for land use. We had software, we could develop this field. I have this booklet here from the year 2000, the geographical imaging in Poland, if anybody is interested. So there is a lot of tradition, many companies like that today. Talking of technology, the technology needed to share data. Monica, could you please summarize these technologies briefly? Well, this is quite a revolutionary situation where we have a lot of data from satellite observations of Earth, Earth that we want to share with everybody, not just individual scientists, but everybody, every natural person. To do so, we need to first of all be able to input the data. We have to index it, we have to store it safely, but also in a way that will enable its later sharing, which is quick and easy. All these technologies, well, we have to learn what data that is. Sometimes we have to help data processing. We have to use some cloud resources because not everybody wants to get the data back. So these are all technologies based on open source tools, and these technologies have been developed by us and are being used for normal everyday services in a range of platforms like the mentioned Creodias, because there is also Bekeo, there is EOLab, there is Codee, there is the long-term archive for ESA, there is the HPC project also from ESA. So all these technologies have been used multiple times to deliver services to demanding clients, to clients that base their businesses on these solutions. Kuba, over to you. How do the entities of the Polish space sector, how did they contribute during the last 10 years to the improvement of Polish residents' safety? Well, from the very beginning we knew that when developing the space sectors, we cannot think only about technology development. The technology has to serve people, and one of the areas where it seemed obvious that this value added is measurable was safety, using the observation of the Earth, not just observation, but also observation in crisis management. In 2013, under the umbrella of the Space Research Center, the Crisis Information Center was established that tries to be a hub that has its own competences, but also makes it possible to reach the information from all the Polish entities to be used. Quite slightly earlier, in 2010, it was the year of the Great Flood in Poland, and fortunately it was, well, the biggest and only case where satellite pictures needed to be used that were analyzed and processed by 6 different Polish entities working together. This actually made it possible to monitor the flooded areas, to recommend actions for the removal or its consequences. This is an example of the scale of an action that was implemented when it was needed. In the 10 years, it was also possible to systematize this. Today we have 9 products, not just of the Space Research Center, but mostly of other entities that are defined, that are ready at the national and at the regional level. Crisis management centers, when they need them, can request them. Interestingly, this also happens as an element of cooperation with ESA, because this is one of the recent projects of PLEASE. What do I want to say? We have the skills, we have the users, we have users who are open, users who have been through this evolution. Like in the past, I got a phone call that an intervention from Copernicus service was needed, and now they have their own people who are trained, and they themselves start this service, but at the same time they are open to new things, they are open to experimenting. The space opens the way to broader geoinformation.
We connect space and the path, the way, in order to make a full picture, to assess the risk and respond to the risk, and this is happening. So I would say that today Polish space sector and Polish recipients of this kind of data information show that the space is valuable, can be valuable for the administration, and because of that can be valuable to every resident of our country. Monika, again, where did the idea come from to build the competences in Poland in the area of dedicated cloud services for the space sector, as well as storage, processing and sharing of Earth observation data? Was Poland's participation in ESA a spark for such action? Yeah, shortly speaking, yes, but to tell you more, yes, Poland's membership leadership in ESA and the fact that the ESA actually placed this challenge ahead of us. So there will be a Copernicus project, there will be a lot of data, and everybody need to have an easy access to that. So please give us a good solution. This is what ESA said, and we tried to just deliver this. Thank you very much, ladies and gentlemen.
Nasza podróż kontynuuje. Przechodzimy do kolejnego tematu bezpieczeństwa
kosmicznego.
Już tutaj radiowołanego zapraszam do rozmowy pana Piotra Sybilskiego z Pana Michała Żojnowskiego i pana Krzysztofa Stampa
and Krzysztof Stamp from ITTI.
Dobrze. Pierwsze pytanie do Piotra. Jak rozwijały się polskie zdolności obserwacyjne w zakresie
Polish observation capabilities in the field of observation of satellites and space debris developed? Shortly speaking, very dynamically, but now, referring to this motto, yesterday, today, tomorrow, we've heard today that we are the third when it comes to delivery of optical data in the USSA consortium in Europe. This is today, but tomorrow we hope to be the first ones in Europe. And then we hope to, as a sector, as Poland, we hope to be #1 in the world. We are talking about the optical observations and optical sector. How did it develop, and how is it possible that here from Poland we are able to compete in Europe and globally? Well, it was done because it is possible for us to use very good foundations done under the scientific projects such as Space Research Center and universities, Nikolaus Copernicus Center of the Polish Academy of Sciences, and they are centers that are very well known because of their activities in space, connected with space, astronomy and so on. We have to thank the Polish administration, Ministry of Technology and Development, Polish Space Agency. A good coordination with the ESA created conditions that made it possible for us to build this kind of dynamic and developing sector in this scope. Well, I can quote some numbers for you. What we started in 2012, well, we had only few observatories. Today we have 30, 40. In a year we will have 50, 60 of them. And that's not the end, because they should be around 100 of them. The observations were done on the level of several 100,000 measurements every day, and today it's million daily. Is it the end? Well, no. A billion should be done within one day. So this is the good cooperation between the companies and the science world, as well as the public administration, Space Agency and ESA. Thank you very much. And now, what is the role of Polish companies in the so-called planetary defense or monitoring the asteroids that threaten the Earth? Well, that is a very interesting word, military defense. Most of us may be really associating that with Hollywood movies and heroes wearing special clothes, obviously, but that's not exactly the truth, because sometimes we are just are wearing our pajamas in the evening already, watching Netflix movies, and then we get a message that there is an object coming closer to Earth. So for another several years, several hours, it can be a threat to Earth because it may collide with our globe. And Polish telescopes have been very actively participating in the projects run by ESA in this kind of field. So we checked the location of the object that quickly approaches Earth. We have the special region instrument to calculate the orbit, and we will know whether this object will hit us or maybe omit us, hit the atmosphere. And since we are today very healthy and existing, well, we can guess that there are no big objects that hit Earth recently. But the threat that if this is not really a big object, then maybe a rock of the size size of a TV set or a car may really collide with Earth orbit, and this is what Polish telescopes are doing. Thank you very much.
Thank you very much. While watching Netflix, I will know that someone is watching for my safety. Krzysztof, over to you. What are the areas of space safety where the Polish entities are involved, and where should their role be increased?
Myślę, że tak, mamy dobrą informację.
Well, we have good, the good news is that we operate in all the areas, the three main areas of space safety. So the planetary defense, observation of objects close to Earth, observation of satellite and space debris, and also space weather. We have instruments, which was also been shown in the different presentations. We have specialists who know how to operate the instruments, and we have different tools, equipment, we have software and hardware that help us cope with that. This is also reflected in the fact that we are able to participate in the projects at ESA. We can take part in the tenders, and the use of the contribution in this scope is quite considerable. So what I believe we should keep focusing on is something that was already mentioned, the participation in space safety missions. Professor Stanisławska showed the clear space mission. So these are the things that we should keep being involved in. That will require time and involvement, of course. What I can add is that I believe that as regards space safety, we have had quite a good approach from the very beginning. More or less at 2017, we had a solid stock taking of what we had and created certain roadmaps that we are still using. And if we don't know what to do, we look at them and try to use that resource. Thank you. Thank you. Piotr, back to you. Infrastructure. What particular sensors do Polish entities have for space safety? The sensors are dispersed across the globe. On every continent apart from the Antarctica, we have sensors. Antarctic, we have sensors for observation of space debris and asteroids and satellites. In Poland, we have an observatory for space weather that will support us. But this is not just about sensors, but also the software that controls them, and research centers, industrial centers that analyze these data and delivery of services based on the data. There are several such centers, and this is a very dynamically developing area where I think we can be competitive on the international arena again, and we are beginning to appear in such commercial tenders. This is quite exceptional that we can achieve this level of competitiveness in such a short time. So these resources are telescopes, people, and also software. Thank you so much. Krzysztof, the last question to you. How important is the software in the area of space safety, and what are the skills of the Polish entities? We definitely believe that software is extremely important. Some say that this is the heart or the brain, that the software is actually the heart of the brain. This is a integral part of every system. We have quite extensive skills for software development, for development of the catalog of objects, the service or visualization of different sorts of data. We can process the data, we can work the data, we can store it and distribute them to the relevant people. Also, the National Operational Center has been created, so it should have the software that we fully control here in the country. When we think about the situation of our neighbor, Ukraine, it shows that this is very necessary for us to be able to act and to fully control this infrastructure and this software in order to be able to operate it properly. So these are big words, but big software strongly affects our sovereignty. So I will finish with that. Thank you very much, gentlemen. And over to the next part, electronics and communication.
Panią Monikę Świerszczypańską z Thorium Space Technologies i pana Macieja Króla z
Polska, Monika Świerszczypańska from Thorium Space Technologies and Mr. Maciej Król from VIRAM.
Pierwsze pytanie do Tadeusza.
So the first question for
Jakie technologie
Tadeusz,
elektroniczne, a raczej elektronika, do jakich zastosowań jest obecnie
what
rozwijana w
applications is currently being developed in Poland? Thank you very much for this question. Well, electronics in space, especially in the area of satellite upstream area, has many applications. This may include feeding modules or control mechanisms of scientific instruments, modules that support communication, optical or radio communication, or passive electronics that focuses on radio connection between the ground station and the satellite. Well, in each of these areas we have 1, 2, 3 companies with skills and competences to develop in these fields and deliver the electronics for projects run by the ESA or projects financed by other sources. So here, when it comes to the categories in which we can be the most successful, are these categories which are new categories in ESA, for instance, optical communication or quantum communication, and this is the type of electronics done in Poland. Well, I'd like to also ask you about the ESA optional programs, which are the most heavily used when it comes to space electronics. As I said it before, the electronics can be applied throughout every single programs run by the ESA, for instance, GSTP program, where the generic technologies are developed, but this includes also very specific solutions, for instance, the orbiting mission, collecting the debris, where the space debris is captured by the satellite that is doing the mission. Monica, now over to you. What are the unique competences and skills in the field of satellite telecommunication do Polish entities from the space sector have? Well, let me start with saying that those skills are unique. Indeed, these are not just the competences that are just part of the European ecosystem, but they are not particularly innovative. Indeed, Polish companies and institutes and research units develop satellite telecommunication and their skills in this field, and they are unique. Not just on European scale, but on global scale. We manufacture innovative electronic elements, passive and active, both. And we are able to do the fully electronic harness control technology, which is groundbreaking when it comes to the satellite communication. Well, that also helps us to ensure the access to the broadband, which so far was hard to achieve, and we are able to very flexibly manage the throughput, and we are able to ensure the signal for the safety of the state, which is extremely resilient to dumping, and we are able to respond to the needs that result from safety, security of the country, administration, public administration, and all of us. And Maciej, I have a complementary question. In your opinion, did Polish entities start from scratch in 2012, or did we already have some experience when it comes to the solutions for the space sector? Well, before 2012, it was mostly the experience that was connected with the technological universities. 76 center, and then 77 the flight of Mr. Romaszewski, Hermaszewski, and I'm talking mostly about the Warsaw University of Technology. But in order to develop, we needed money. We needed millions of of euro to develop, and the companies have no such money. So then we had the police program and other programs, GSCP or ARTES programs. These are the programs that make it possible for us to develop. Let me give you the example of the company that signed the first contract in 2016 with ESA. Today, after 5 years, they are doing the 7th or 8th project for ESA.
So it must be pointed out, I will quote what has been said at one of the ministerial conferences. Funds are needed for the development of this sector, but first of all, flexibility in spending the funds, because for Polish companies this is a new road, and it is not fully known on what conditions these funds will be spent, because one doesn't make profit on this money. It is used to finance the development of the sector and preparation of certain technologies. So, to sum up, I believe that commercial companies in 2012 were just beginning, and it is only today that we can obtain such relations between companies, build satellites together. It was also mentioned a lot of companies provide components for the satellite that next year will be the first non-nano satellite on the orbit. Monica, Polish entities from the area of satellite telecommunications, can they compete with the other entities, other countries' entities? Yes, there is a lot of interest in the skills of Polish entities from big system integrators, from satellite operators, from internet providers, and this interest confirms that what we are doing is not just innovative but also competitive. Also, as regards ESA programs, it is enough to look at the ARTES program, and the topics of the tenders under the ARTES program, they ideally fit with the skills of Polish entities. There is a bigger and bigger awareness of the skills of the Polish entities, and not just in Poland, also in Europe and globally. The best proof here is that the moment has arrived when big players, integrators, satellite operators themselves come to Polish entities, initiate talks, and are determined to cooperate with Polish entities. Thank you so much. We continue on the journey. Now instruments and structures. I'd like to invite Piotr Orlański from the Space Research Center of the Polish Academy of Sciences, Bartłomiej Płonka from the Silesian Scientific Center, and then also Ewelina Zaremba from Scanway.
Dziękuję pięknie. Zaczniemy od pana Piotra.
Thank you so much.
Panie Piotrze,
let's start with Piotr. In the last 10 years, for which missions did Polish entities provide instruments? I have a problem here actually, because I like to start by saying that building of instruments and participation in research missions is one of the most effective ways of cooperating in space, and our participation, Poland's participation in space, Poland's involvement. But there are so many instruments that I am bound to forget something, or I will not have enough time to list them all. In 2012, we joined ESA, but several projects were already underway. And in 2013, the Herschel mission ended, one of the most technologically complex missions. And in that mission, we participated in building of the largest instrument. In 2013 and 20, actually even earlier, we started building the set of instruments for ASIN mission, for the space station. It was 2005 that we started, and we finished in 2018. I will get back to that. In the meantime, there are two BRIGHT satellites, the first Polish scientific satellites that were to operate for years on the orbit. They were integrated in the center and launched in 2013 and 2014. And they are operating until today. And like with Integral that has to be maintained on the orbit, also these satellites are bringing very interesting scientific information. Then, maybe without the dates this time, there is a Piccolombo and the Mercury mission where we participated in building of the spectrometer. Then there is the Cassis, that is ExoMars, and the Swiss, Polish, Italian stereoscopic camera that is still orbiting around Mars.
And then we had the ASIMO, the set of instruments working on the space mission, the LERO. Also the project in this station. We had inside NASA mission on Mars planet and digging into the planet, and we had solar orbiter that I have mentioned. It flew and now orbits around the sun. Chang'e, so the Chinese mission, lunar mission, where our instruments were working, and what is happening right now. Next year there will be a JUICE launched. We have 2 instruments there, so plasma waves and spectrometer. The infrared. Then we had a very advanced technological and scientific mission, 2 satellites that will be combined together, and this is where we built together with Polish industry the whole computer for the scientific complex, and for that we need another conference actually to, well, I am reaching the end actually of my list. Athena, a very big mission where we participate in 2 experiments, Ariel that was mentioned here, and a system, very advanced system and scientific instrument, Comet Interceptor, so intercepting a comet that is unknown yet when it comes into the and appears in the solar system, and we are trying to participate in LISA. And as Poland, we, I think, have 8 contributions to MIF, the competitions that are taking place right now, so most probably Polish instruments will be part of those missions as well. And I think this is the end. Yes, we were able to list some of them. I'd like to apologize if I failed to mention anyone. Bartłomiej, what was the process of entering the structure production technologies like, and what has been achieved so far?
No.
In order to answer this question, I will have to again go back to 2012, mentioned so many times today. One date was skipped, the 1st of September 2012, and in our company we switched on the light. Our company was built from scratch on post-industrial area somewhere in Silesia, in the city Czechowice-Dziedzice. This is a very tough word to say for a foreigner, so we switched on the light in 2012, knowing nothing about space structures, but with the help of the Polish Industry and Entrepreneurship Development Agency, we went to Berlin Fair, and this is where we met with the representatives of ESA and Elena Space Concern. And under PLIS, we started a technology transfer program, structure manufacturing, so carbon panels, flat panels manufacturing, but also 3D structures as well. So honey, plaster as well, and carbon actually made. So these are used to manufacture or make big spaceships, satellite platforms and modules for space stations that are supported right now by the Space Agency. And after the 10 years of our operation, I think that we are surely the only entity in Poland that is able to do this kind of structures. What's important, those structures are not just manufactured just because we actually completed a few contracts, and those structures are right now integrated into the communication satellites and they all are launched. So during the past 10 years we were able to do something from scratch and to reach this level that we are able to do the flight structures.
A question to you. Who is currently the clients for instruments and structures? More and more, the clients are companies, commercial clients, which is good to see because nothing is as developing as commercial cooperation. Structure integrators, satellite structure integrators, and their clients who want to do tests in space. And that's two-directional. As companies from the sector, we are not just the provider, but also a client for certain elements that we need for our missions. Companies focus on what they are best at, and the rest of the elements needed by the mission they can find on the market. The main drive for the development of research and development projects are projects funded by public institutions from programs like Horizons or also from ESA. More discussions about programming for space sector. Michał Mozdorf, N7 Space, Ambroży Bido-Sokołowski, GMV Innovating Solutions, Julia Maruszczak of KP Labs. A round of applause for you, please.
2 minuty.
2 minutes.
Przyspieszamy, bo ten panel jest przed lunchem.
So we need to speed up because this panel is before lunch, and I don't want people to blame me. What are the technological areas where software companies from Poland can play a key role in the coming years? Thank you very much for this question. Now the situation is as follows. The companies present in Poland can provide both low and high level software. Thinking about the future is where to think about software development not just as a service but as a product, thanks to which this product can be easily used without being dependent on a specific context of a space mission. And here we are helped by different technologies that have to be used during production, such as engineering based on formal models, thanks to which the code can be generated from models describing the system, which actually reduces production costs considerably, while improving the possibilities of other use. Another interesting area is the development of software for new computer system based on complex processor, enabling high efficiency computations, and also application of new languages that also affect the reliability of on-board software. Ambroży, question to you. What are the types of on-board software and are they produced in Poland? Software is everywhere. Software is everywhere. For rockets, for satellites, for probes, they all have software. And like Michał said, there is a low level and a high level software for platforms, more connected with platforms or connected with the instruments or with the sensors, well, to control the devices. It seems to me that there is more and more software and more requirements from software to include more functionalities that can be conducted from Earth on board. I mean autonomy, for example, where this is a very interesting topic indeed, which will be present on most satellites and probes in the future. there is also the high-level control, precision control, and precision navigation for satellites and for probes and for rockets. And we can also talk about the functionalities closer to instruments or to data processing on board. There is the development area, and that is already interesting for Polish companies. During the 10 years, during this period, it seems to me that a lot was being built, new technologies in Poland, new software technologies in Poland, and this process of validation and creation for the space sector, which is quite specific, we have to say. And we were building we were basing on the students, on the staff who were very efficient developers.
And in the future, we're supposed to work in the space sector. And now it seems to me that we used this software in space in several small missions. And right now it's time for a bigger participation in the future instruments or missions, bigger missions run by ESA. And Julia, the question for you.
Przeszłość i przyszłość, czyli jaki był wkład polskich firm w
past and future, what was the contribution of Polish companies to ESA missions related to artificial intelligence, and what kind of crucial role can be played by Poland in future missions? Well, the future is happening now because artificial innovation is a very interesting and innovative subject, and more companies want to try to implement it in their operations. Well, when we talk about space, it is mostly supported by AI when it comes to observation of the ground here in Poland. And more projects require AI on board. So, for instance, analysis of telemetric data, we create algorithms to process data on the orbit, to prepare the data for processing. So super resolution reconstruction. On board we have satellites, and with the AI we are able to identify the metal, the clouds, and a lot is happening, and Polish companies are very actively participating to it. And not only they create algorithms and software, but also the hardware that will be installed on board of the satellite and will help to launch this kind of mechanisms. And year by year this hardware becomes more advanced. And right now we are preparing instruments for mission observing the Earth, but also it will be necessary in SSA, in telecommunication areas. Polish companies are already creating, manufacturing OBSET 1, and in the future OBSET 2 satellites. AI algorithms are launched on OBSET 1 on board. We are part of the mission FuSat 2, and still a lot has to be done, but a lot is happening. Michał, now the question for you: what are the main target markets and customers for Polish software companies? Well, in the past 10 years, a big market was connected with ESA, where Polish companies were able to do the projects connected with the onboard software for scientific missions, but also for demonstrators. And of course, there was a big participation of companies in the technology development projects and product development projects, products that must meet certain standards in order to be used in the future space missions. And the biggest success, business success of the past 10 years was the fact that we were able to have the products that were developed with the funds of ESA and national programs, and they reached this kind of advancement and progress that allows them to be commercialized beyond the ESA, so by clients who are strictly commercial clients, not connected with the ESA.
Dziękuję wam bardzo.
Thank you very much, ladies and gentlemen. Please take your seats.
robotyki kosmicznej i
And now we are
mechanizmów.
moving on to the
Na
space
scenę zapraszam
robotics
pana
and
Maksymiliana
mechanisms.
Gawina.
And I'd like
Brawa
to
oczywiście.
see Maximilian Gawin
I brawa dla
here.
wchodzących jednocześnie.
A round of
Maksymilian Gawin,
applause.
Astronika, Mateusz Wolski,
Maximilian
Piat
Gawin
Space
from
i
Astronika,
Jędrzej
Mateusz
Baran,
Wolski
Centrum
from Piat
Badań
Space
Kosmicznych.
and
Maksymilian, zaczniemy od Ciebie.
Maximilian,
Jak
let's
widzicie
start
strategiczne
with
obszary
you.
robotyki planetarnej? Czy Polska ma
What are the
szansę?
strategic areas of planetary robotics and
robotyka
does
satelitarna to
Poland have a
dosyć
chance
szeroka
to
grupa
participate in them?
działań, które
Well,
można
the
byłoby
planetary
zabrać w trzy takie
robotics
grupy.
is a big group
Czyli to
of
byłoby
activities
badanie
that could be divided
powierzchni
into
obiektów
three groups.
kosmicznych
So,
za pomocą penetratorów,
researching the
wiertnic
surface
i
through the
instrumentów
penetrators
naukowych, które
and
analizują
drills
te
and
próbki.
scientific
Działań,
instruments
które
that
powiększają
probe
mobilność
and the activities that increase
tych
the
ciałach
mobility
niebieskich,
on
jak Księżyc czy
the
Mars, oraz
celestial bodies such
przygotowanie
as
infrastruktury na budowę
Moon or
stałych i
Mars
czasowych
or
baz dla człowieka.
preparing
Te bardzo
temporary
ekscytujące
or
działania
permanent
pozwolą
bases
człowiekowi powrócić na
for
Księżyc, potem go skolonizować i potem
humans
ruszyć
that
w
will
kierunku
actually
Marsa i
help
też
humans
innych
to
ciał
first reach Moon and
Układu
then colonize
Słonecznego.
it and then go
No i
for
co
Mars and
najważniejsze dla
other
polskich
celestial
firm,
bodies
to
of the
polskie
solar
firmy już
system.
są w takich
And
działaniach,
Polish
mają
companies
dosyć
are
szerokie
already
doświadczenie
doing it and they are quite
i
experienced
mogą
in
to
this kind of
wykorzystać. Już teraz
operations
w
and they can
Polsce
use it.
mamy choćby
Use
ramiona
this
robotyczne,
expertise.
które mogą być
For instance, we
wykorzystywane w
have
takich
a robotic
sytuacjach,
arm in
szeroką
Poland
gamę
that could be
mechanizmów,
used
które
in such
mogą
situations
działać w takich
and apply
środowiskach,
a series of
technologie
mechanisms
wiertnic,
such as drills,
technologie robotów skaczących,
jumping robots
elektronikę,
technologies,
dla takich
electronics,
obiektów. Także
telecommunication. This is what we do for those kind of instruments. So we can imagine a rover that could be made from Polish components only, and this kind of rover could land on Moon or Mars and use the rocket technologies also developed in Poland.
So this is a big chance for integration of the Polish space sector. And in the years to come, use of the synergy effect and increasing the benefits and achievements. Let's talk about business synergies. Over to you, Mateusz. What is the commercial potential of the orbital robotics? According to different estimates, by 2030, this segment will be worth between 5 and 7 billion euros. But looking at from the perspective of the Polish companies, we are talking about 12% of this sum, several hundred million euros. This is a big amount that encourages institutional investors that are considerably active in the segment of robotics, like the Agency for Industry Development. It encourages them to invest in companies, to scale them, for the companies to become an attractive partner also for the public administration, because then they will not just ask for grants for the development of their technologies, but come bringing their own money that they invest in the development of strictly commercial technologies to cater to the non-institutional market. Andrzej, 10 years ago, when we were becoming the member of ESA, the Polish industry and the Polish academia had some experience regarding the mechanisms and robotics. What changed in the 10 years? How did this area increase? Like you said, the Polish industry and the Polish research institutes and technological institutes already had quite extensive experience and considerable skills as regards advanced engineering techniques for mechanisms or structures. So what changed in the 10 years of cooperation with ESA is certainly that to these already high skills of performing mechanisms that were tested in action after being delivered by the Polish entities. So the new thing was a lot of knowledge about system engineering from the area of system engineering, formal and analytical demonstration that our devices can also fit within broader systems. I could list the participation in two big European projects where this mechanism, apart from doing what it does as a standard, like performing its function very well, surviving the difficult space environment, it also has to fit a big consortium of many entities, be well integrated, and carry this potential for change. So we learned this mature project growth that enables us to do things on an even higher level. Maximilian, about what Jędrzej said, can Poland become a provider of ready components and key products for space missions? Yes, definitely. I think that the product approach and the approach to the delivery of ready subsystems can be a second leg for very ambitious exploratory missions. The second business leg, securing the safety of the Polish industry. Now there is a lot of demand on the market for the mechanisms such as antennas, solar panels, opening systems, and others. Already we have entities in Poland that have the technologies, that have the devices, that have the status of a product or are very close to it. And now I would focus on helping these entities with completing the qualifications and tests for these products to be delivered to integrators, to big European companies. And such cooperation, delivering the components to European companies, would open up our entities to using their experience and knowledge, and then open up the way to integrating bigger and bigger systems for these entities and entering the road of the big European corporations.
Thank you. And now, what is the chain value of satellite service technology in Poland? Looking from the beginning, it's worth to emphasize the role of scientific centers, for instance, CBK, PAN or PIAP Institute, FU, technology universities such as AGH and Warsaw University of Technology, and that helped to create spin-off and spin-out companies, Astronika, for instance, Capspace, that develop those kind of technologies here in Poland, but we also have foreign investors here, Saner and GMV, that simulate competitiveness of Polish sector. We also have an active participation of primes, such as Thalesalenia Space, that help to increase the quality and values solutions in engineering used in our products, and that makes that this whole ecosystem is a living organism and very competitive. And there are also social organizations that actively work here. For instance, Mars Society Poland or European Space Foundations or New Space Foundation. Well, those organizations help to win the contracts, and because of that, the whole robotic group is very competitive and they complement each other. Now, Tomasz, in what directions will the area of mechanisms and robotics develop in the next 10 years? Yes, I think, as Mateusz has mentioned this, I see it this way, and many people from the industry agree with me. So the further development based on R&D projects where the technologies are developed to be placed on the shelf, so that in the future it will be applied realistically and physically, and this is working very well as the cooperation between the R&D institutes and the companies, and I would expect that in general the space industry is developing. I would expect to see more commercial solutions that must be delivered to the market. So still the research technological missions, big ones run by ESA, will be kept, maintained, but it will be more often that they will be based on the commercial needs. So for instance, a lot of mechanisms that need to be delivered to the mission. For instance, robotics may expand so much in the future. So I expect bigger commercialization and the need to deliver solutions, more commercial solutions in the technology area. Thank you very much, gentlemen. Now
Zapraszam na nasze krzesła.
Please take your seats here.
Jak Państwo widzicie, wizualnie nasz sektor kosmiczny rośnie cały czas na scenie, a to jeszcze nie koniec. Przed nami jeszcze dwie rozmowy. Do kolejnej rozmowy o systemach satelitarnych zapraszam pan Jacek Kosiec, Kreotech Instrument, pan Radosław Łapczyński z SATREF i pan Marcin Sarnowski z Space Forest. Brawa oczywiście dla Państwa.
And a round of applause for our guests. on the stage.
Zaczniemy może od potworek. Marcinie, czy osiągnęliśmy już w segmencie systemów satelitarnych, co osiągnęliśmy po tych 10 latach obecności w Europejskiej Agencji?
Od kilku godzin rozmawiamy o samych sukcesach, więc tutaj z racji ograniczonego czasu nie będę ich wszystkich wymieniał. Skupię się może na tym, co jest najważniejsze. Najważniejsze jest w tej chwili chyba to, że już nie jesteśmy w roli takiego małego chłopca, który się uczy na tym rynku robić pewne rzeczy. Coraz częściej jesteśmy zapraszani do dużych misji kosmicznych. No i coraz częściej składamy w propozycjach dla Europejskiej Agencji Kosmicznej. Chwalimy się nie tym, co możemy, nie naszym potencjałem, tylko przede wszystkim naszym doświadczeniem. W przypadku, kiedy średni projekt rozwojowy w ESA trwa 2-3 lata, my po 10 latach jesteśmy w stanie już pochwalić się pracą nad własnymi satelitami.
We can say that we are working on our own satellites. Jacek, question for you. What are the key skills, the crucial skills in this area? Well, I think that if we are growing from single components through module subsystems, then at a certain point we will reach the level of systems. And those skills had to be built and developed in Poland because in general system engineering in Poland was not a very strong field. And so when in 2014, as far as I can remember, we had experts from ESA visiting us and we were expressing our ambitions that we would like to reach this level of systems, especially the whole satellite systems. Well, they were just not convinced that this is possible. And I would like to say that we have a witness here. So MGSat-1, this was our first project that was actually submitted as the level of our submissions, and nobody believed in us at that time. And I think that we can talk about single satellites, but also constellations of satellites and
or even higher formations of satellites. We can talk about systems of systems, and this is the level of our current ambitions. Moving on to the technology level, where are we as regards the building of components of subsystems? It depends what components and what
products. What those three pillars gave us as Polish entities that are able to operate in launching technology. These are suborbital rockets that based on hybrid propulsion,
mobilne wyrzutnie,
mobile
czy też
launching platforms,
to jeżeli chodzi o system wynoszenia, a także mamy produkcję wysokostężonego natlenku wodoru, zielonego propelanta, które jest też jako zielone paliwo
which is also
bardzo
a green kind of fuel that is a desired component. We can,
dzięki uczelniom, które
with the help of
pracują z złożami katalitycznymi do rozkładu natlenku wodoru, są w stanie to produkować. A także to jeżeli chodzi o produkty, jeżeli chodzi o usługi, również mamy szeroki zakres badań kompatybilnościowych, materiałowych,
material and analytical scope and resilience, strength, capacities. So, with the help of the investments of the companies, universities, and with the help of the cooperation with ESA, right now we are the most developing sector in Poland.
Jak rozwijamy w Polsce technologie rakietowe mogą być wykorzystywane w satelitach
rocket technologies can be developed in Poland, and how can be used for satellites and exploration missions. So first of all, the engines or propulsion components for the platforms, satellite platforms, electronic platforms that are developed in Poland, but also for scientific satellites. But we are talking about green propulsions as well. but as part of big missions, we can work out Polish standard that can be a standard for the institutional missions of the ESA, because we also develop the technologies of the components that are not under ITAR regulations. So we are in the gap of the valves, European valves dedicated to various purposes. So technology of big rockets as well. Here we do the first in the world engines that are propelled by green fuels. Actually, that actually helps to use a demonstrator or maybe planetary lunar ships to land, for instance, on the surface of various planets, and that helps us for the future exploration. Thank you, ladies and gentlemen, and a round of applause.
12:30, nie wiem jak mi się to udało,
ale skończyłem perfekcyjnie, I don't know how I did it, but I actually went according to the agenda. So that was a very brief journey
Brawa jeszcze raz dla naszych rozmówców. Szczególnie podziękowania ode mnie za przyjęcie tej formuły nietypowej. I szanowni Państwo, myślę, że to jest dobry czas, żebyśmy sobie zrobili wspólne zdjęcie, po to tu jesteśmy na tej scenie. Duże zdjęcie, żeby pokazać reprezentację polskiego sektora, a ja oddaję dosłownie na głos do siebie.
Dziękuję, gratulacje Łukaszu. Dziękujemy, szanowni Państwo. Faktycznie rzadko się zdarza, że na jednej scenie tak różnorodnie i mocno silnie reprezentowany sektor kosmiczny, polski sektor kosmiczny w jednym miejscu się znajduje. Zachęcam zatem Państwa do wspólnego zdjęcia, zachęcam fotografów do wykonania takiego wspólnego zdjęcia. I już nie przedłużając, chciałam Państwu podziękować i po wykonaniu tego wspólnego zdjęcia zaprosić na przerwę, która potrwa do godziny 13:30. Dziękuję.
1:30. Thank you very much.
Jako rozwiązania, z których korzystasz na co dzień, bezdotykowy termometr, zestaw słuchawkowy czy nawigacja w telefonie. To przykłady niektórych z nich.
Brzmi kosmicznie? Sprawdź to.
Europe is at the heart of new space ambitions, ready to embrace ever greater technological and human challenges. The first objective is to maintain autonomous launch capabilities for our missions. Based on 50 years of experience in launchers, we can ensure space transportation for future missions. In orbit around our home planet Earth, the International Space Station continues to play an essential role as a research platform. Soon it will be possible to journey in the Orion service module to the Lunar Gateway, a station that will orbit the Moon and be the first deep space outpost supporting human exploration of the Moon. By the end of the decade, a European moon lander should deliver the cargo needed to survive the lunar night in a base camp, securing a European astronaut's presence on the Moon. But to secure our independence, shouldn't we find a way to get there ourselves? What if Europe were to develop its own crewed transport system? The Space Rider demonstrator is a step in that direction. Striking out beyond the Moon, we'll send the Sample Fetch rover to Mars to collect samples and bring them back to Earth, so scientists can unravel the mysteries of the Red Planet. Many other missions will be key to prepare for human exploration of our sister planet. Let's take part in those first steps. And why stop there? There's a natural satellite around Saturn named Enceladus, which may also harbor life. Isn't life the very essence of our planet? Together, let's explore space, traveling farther, so as to come back with new knowledge to improve life on Earth.
Technologie kosmiczne wspierają nas w codziennym życiu. Dzięki obserwacjom satelitarnym możemy prognozować plony, przewidywać skalę powodzi, zasięg pożaru, a nawet monitorować stan naszej planety.
Brzmi kosmicznie? Sprawdź to.
Czy wiesz, że technologie kosmiczne pomagają nam dbać o zdrowie? Skanery medyczne, odporne na zarysowania szkło wykorzystywane w okularach, czy laserowa operacja oka? To tylko niektóre z przykładów.
Brzmi kosmicznie? Sprawdź to!
Technologie rozwijane przez sektor kosmiczny to nieodległa galaktyka. Obserwacje satelitarne mają bezpośredni wpływ na nasze bezpieczeństwo. Wspierają ratowników medycznych w niesieniu pomocy.
Brzmi kosmicznie? Sprawdź to!
Houston, Tranquility Base here. The Eagle has landed.
It's 60 years since humans first went into space. By using rockets and developing life support systems, we have learned to live and work in orbit around our planet. But we dream of exploring farther, to set up home on the moon and beyond. ESA selects astronauts from our member states to train for and complete our missions. To be an astronaut, you must be experienced in technical work and healthy enough to fly to space safely. Once selected, astronauts try to fly in space and to conduct a whole range of experiments there. Our astronauts train with partners agencies around the world, and particularly at ESA's Astronaut Center in Cologne, Germany. ESA conducts special studies on the ground to prepare for missions in space. Our home planet has extreme environments where we can train astronauts and test equipment. We work underground, in volcanic landscapes, and in isolation in the Antarctic. We test tools in rocky landscapes and create and store materials that resemble the surface of other planets. We also create elements of the space environment. We use bed rest and parabolic flight to test the effects of weightlessness, as well as Mars yards and lunar bases made with simulant dust. The International Space Station is one of the most amazing machines ever built. A huge international team worked together to make a laboratory where astronauts can run experiments to help life on Earth and our future lives in space. As well as doing their daily experiments, astronauts on the station need to be able to monitor their health and well-being and support their fellow crew members. They communicate with the ground regularly, including with flight controllers based in Europe. Some experiments and repair work on the space station require astronauts to go outside. They wear spacesuits to conduct extravehicular activity, also known as spacewalks. Spacewalks are rehearsed in detail, using deep swimming pools to simulate the weightless environment. Spacesuits are brilliant machines, like small spacecrafts in themselves. But we would like to make them smaller and easier to move around in, especially for walking on the Moon and Mars.
Drodzy Państwo, jest mi niezmiernie miło powitać Państwa na części popołudniowej pierwszego dnia konferencji 10 lat Polski w ESA. Wczoraj, dzisiaj i jutro. W trakcie tej sesji poznamy wyzwania, przed którymi stoi dziś Europejska Agencja Kosmiczna. Uprzejmie proszę o zajęcie miejsc, ponieważ będziemy zaczynać za 30 sekund. Proszę o zamknięcie drzwi i będziemy zaczynać.
Please close the doors and we will be starting now.
To ogromny zaszczyt móc powitać wśród nas bardzo liczną reprezentację dyrektorów z Europejskiej Agencji Kosmicznej. Zapraszam na scenę pierwszą z nich, panią Simonetę Kelly, dyrektor ESA do spraw obserwacji Ziemi.
Good afternoon, and very happy to be here in Poland, in Warsaw. It really reminds me the time. I want to give you a personal note. I've been involved with the relation ESA-Poland for many, many years. We saw this morning my colleague Eric Morel reminding about the various steps of the accession of Poland into ESA. We are celebrating here today the 10 years anniversary, and I'm particularly happy to see the evolution of the Polish space sector overall, the incredible multiplication of industries in the field, the increase, of course, also in the investments in the agency and the collaboration. And really happy because I was involved since the 90s, since the first agreement and then in the accession. So this was my personal touch, but I must say, also having met some of the industries this morning here and the representative of the Polish Space Agency and the ministry, it's really a pleasure to see a strong evolution of space in this country. I was asked to talk about the challenges in Earth observation and what are they today, and I'll be quite fast because I understand we only have a few minutes and my directors will follow me, but just to put in context what we are doing in Earth observation in the agency. Today, you know, we face quite a number of challenges at local, European and worldwide level. We have the societal development goals. Those were decided in the context of the United Nations, where you have in the goals elements like climate change, food security, resources management, and most of those societal development goals, which are 17, are today supported by Earth observation. You see also here the European State of Climate. This was recently published by the European Environment Agency, and also the State of Climate presented by ECMWF. This includes a lot of data on Copernicus, the mission. We heard also about it this morning. The name here, it's a very important name related also to Poland. And there, the challenges to support the goals in terms of climate crisis goals are certainly supported by the current mission and the one we need to develop. Last but not least, another big challenge we have is biodiversity, managing also the disaster context. And today, what do we do with the missions and the satellites we have operational? We have 14 in operation in the European Space Agency with 3 lines of activities: the meteorological missions, the science missions, and the Copernicus one. We take the pulse of the planet. But we plan to do much more in the future, because it's not enough to just have an overview of what is the state of our environment. We need to have prediction models, also model of evolution and forecast of the evolution of the situation over the planet, and this is what we are trying to do with the new activities we put on the table. In Earth observation, we basically build satellites. This is what we do with the projects team. I have today with me one of the project manager, which is managing in Earth observation all the Earth observation science missions. He's meeting with industries currently, and we build projects and we build the satellites with the project teams in ESTEC and with, of course, European industry and with Polish industry, and I hope we even do more in the future. We are discussing currently, for example, with Polish industry, the potential perspectives of supporting us in the development of small science missions, which are called SCOUT, that we hope to develop after the next ministerial. We manage the mission. We work on CAMVAL. Here I know there's quite some expertise in Poland related to research institutes working on CAMVAL activities, and this is one of the activities we do to prepare for future mission, but also to validate the data that we get from our missions. We also work on the application of the data. This is both for the science community and for users, which are institutional users, but also commercial ones. And we work very much on innovation. And innovation is at the core of also what your ministry does in terms of responsibilities. We have opened the PhiLab a few years ago, which is a laboratory of innovation in the agency where we support new commercial activities related to upstream and downstream. And this morning I saw the intervention of your president of the industrial consortium in Poland, and it's pretty impressive to see the potential and the growth you've had in the field also, of course, of Earth observation related to new innovation activities and commercial ones. Here you have the 3 lines I was telling you about today. The Earth observation program of the agency is very attractive, I would say, worldwide in terms of data, in terms of mission, is the biggest worldwide, providing many data, different type of activities, meteorological science and Copernicus, and we're actually building 41 new satellites which are in the pipeline, and we hope to have much more after the ministerial to be prepared. These are the Copernicus expansion missions. Since last ministerial in 2019, we are currently building these 6 satellite missions. Those are supporting new policy priorities at the level of the European Union. You have missions which in fact support the stock take monitoring, like the CO2 mission that we plan to launch in 26 of the COP21 arrangements. We have a land mission looking at the temperature of the land, very relevant if you think of what happened this summer, for example, with the fire events in France. Here you see the current satellites which are up and running. The last one we launched in Copernicus was an altimetry mission, Sentinel-6. It looks at the evolution and trends of the ocean. Of course, when you want to work on climate change and the climate crisis, you need to have data relevant on the current trend and monitoring the evolution on the trends of the sea level rise, and that is very much contributing to that. But you have many more radar instruments on board Sentinel-1, optical instruments to look at land and support the common agriculture policy, the crop classification, and these days also the current Ukrainian crisis. We've been working very much, and I think this is also a relevant topic for Poland here, using data from Sentinel-1 and Sentinel-2 to look at the crop estimates in Ukraine and have the impact not only of the current geopolitical situation and the war, but also of the drought and also of the reduction of pesticides over the estimates of production in Ukraine. We produce about 300 terabytes daily, so more than 250 that you see here of data from the Sentinels. And here on the right, you have a vision of the Tour Eiffel, and that's not by chance. It's just to give you an idea of the volume and the challenges we have in terms of managing the data today. These disks correspond just to 3 days disk of availability of data from Earth observation missions overall. So this is really one of the challenges we have today ahead in this field, is also to integrate more and more digital technologies, AI, machine learning, artificial intelligence, as I said, into the traditional world of Earth observation. And we're really doing this also with the new programs, and particularly with some programs where we enhance solutions related to the digital world into our traditional work of building the satellites, operating them, and working on the application. And here you see some examples, and I want to mention specifically quantum computing, as I know there's quite some expertise in Poland in the industry and potentially some activities that could be done in this field. On another tone, I'd like to say that Poland has been very active on the DIAS in the context of Copernicus. I think this is a very strong success story of overall having a very strong role in the context of Copernicus, in the data access, in the distribution of the data. Today, what we're trying to launch at the ministerial a program called Digital Twin of the Earth, and we're already working on 2 prototype cases related to research activities related to water management and Antarctica. The digital twin of the Earth, we hope really to get the right funding at ministerial there, will enhance the use, the exploitation of the available volumes of data supporting prediction or forecast in those thematics and possibly even more. And it will have, for those industries and companies who will work on the digital twins, a much potential of multiplier effect in terms of investments, as this program is very complementary to a European Commission program called Destiny, where we are working very closely with DigiConnect on the European Commission side. We work very actively on the support to new space and also commercial initiatives. We have not only the laboratory InCube, the Laboratory of Innovation, which is the PhiLab, with the InCube program, which is a co-funding scheme to support commercial endeavors. We have the Scout missions, and those, I think, can be a very important model, and I'm discussing here today with some companies in Poland, a potential contributor to those Scout missions, because those are missions which are of the order of about 30 million to be implemented in 3 years with science objective, where technologies, new technologies, I listened very carefully this morning to the intervention of your head of delegation, the Polish president also of the Space Agency, where you want to go beyond the current expertise in terms of technologies. You have an opportunity there with the Scout missions, also in the context of the Futuro program that we present at the ministerial. And then we support also new space with the data anchor tenancy schemes, and we buy data from commercial missions, and there we are really building up together with my colleague Geraldine procurement schemes which are tailored to support new commercial scheme, more agile one for buying and procuring data sources which are complementary to the Sentinel ones. So we have a new challenge, not only the big data volumes to manage, but also new space. What do we do for ministerial? We have a very balanced, I would say, and coherent program built with some line of program proposals. I won't dwell into all the details of that, but just to give you the feeling that we've been preparing the program proposals for ministerial for about 1.5 years. We've been discussing very actively with the companies in Europe, with Eurospace, with ERSC, the value-added sector network, and we've been looking also at the potential in terms of economic return of the investments to be done in space. So we've done economic studies associated to the programs that we are presenting, which, as I said in the beginning, respond to challenges. The programs are programs which respond to urgent challenges. They have a long-term vision. They imply collaboration, and they're very coherent. And of course, they also guarantee strategic autonomy in terms of technologies for Europe. This is a very important element today, and we have an element of strategic autonomy in technologies very strongly related to our Earth observation program. And we have, of course, economic benefits. Just to mention a figure, today we always say €1 invested in Copernicus provides €10 return, but also the trend in the value-added sector related to Earth observation is currently delineating an increase with a trend towards the 10% increase last year related to value-added activities in Earth observation. And last but not least, the science excellence, which is always at the core of what we do in Earth observation. Here you see the number of programs going to the ministerial. As I said, I don't want to dwell too much into that, but maybe to highlight a couple of things which are extremely relevant for Poland and EO. Poland has today invested overall in Earth observation in ESA 39 million over the last years. It has an extremely good value for money return in terms of 0.96% geo return with the industrial contracts gained, and it has today a very strong potential to enhance that even further in terms of industry and research institutes potential. Future EO, we've been discussing a lot, is the core of what we present to ministers this time, is preparation of future programs. So if you are there from the start, you then can be part of the meteorological, of the Copernicus missions which are developed, but also of the science mission. Very important to be in Future EO for a country like Poland, as it provides you the entry ticket for everything that is done in the future, even on the operational missions. Technology development, but also application, demonstration of services, demonstration of activities, and in that Future EO program, you have the gravity elements of technology development, and you have the Scout missions, which I said represent potential. Second element I'd like to mention here is the digital twin of the Earth. There, I must say, in Poland, you've acquired a very strong expertise to the work you've done with the DIAS on Copernicus, on the data access, on the platforms that you have developed. And I think this is a new program in ESA, very strategic, because it has, again, an amplifier effect in terms of potential contracts to be gained in the future, not just in the DT, but also in complementary to what is done on the side of the Commission. And just to give you a figure, on the side of Earth observation related to ground segment, we plan to have procurements for about 1.5 billion in the next 2 to 3 years. So you see the perspective eventually. I want to mention, to close my intervention here, just a few success stories of Poland. We have worked very much with a company called Creotech, which is here today on the platform, a NEO Innovation Testbed, and also with Cloudferro. This is a repository for Earth observation data, and really a success story, not just for us, but I think also for Poland. Cloudferro has been supporting the CREO-DIAS, which is one, maybe the most successful DIAS in the context of the Copernicus activities, and we have had activities also on Genesis. So these are just 3 examples, of course not exhaustive, but to give you the feeling that the last 10 years have been very fruitful in the collaboration with Poland in Earth observation, and I'm really looking forward to the next steps. This is the last thing, which is a little bit on the side. We have here with me today Anna Budzikowska, who's my colleague working in the Copernicus team, and we managed just in the last few days to sign an agreement with the ministry, with Polska, and to support Lublin, which in 2023 will be the youth capital, and we are planning with this letter of intent that we just signed this week to establish a strong collaboration with the city to do things to support the youth, and in particular to launch the Copernicus Makers event, which is an initiative to engage youngsters into the Copernicus program and get to know about it and validate the data we have. And with this, thank you very much, and I'll be here all day, so available for questions.
Dziękuję bardzo.
Thank you very much.
Zapraszam na scenę dyrektora ESA do spraw transportu kosmicznego, pana Daniela Neuenschwandera.
Daniel Neuenschwander, Space Transportation Director.
Ladies and gentlemen, good afternoon, and thank you very much for inviting me to this very important moment. I mean, 10 years of Poland in ESA is really a key milestone, and I really would like to warmly congratulate you for that. But I want to congratulate for another point, because what Poland did over the last 10 years, it's like predicting how an engine of a first stage perfectly works. And what you have done here was beyond prediction, because when I look to what Poland did from an industrial and from a research point of view over the last 10 years, I have to say the first stage worked perfectly. Let's now ignite the second one. I would like to run you through a few challenges we have ahead of us in space transportation at worldwide level, and of course also in Europe, and then say a few words about how we want to position ourselves in such a context. So if you look at worldwide level, it's accelerating in all dimensions. In all dimensions, I would just highlight the 4 points here. We have an aggressive competition at worldwide level, but let me be clear here. It's an opportunity, it's a chance. I mean, the offer is increasing in the whole spectrum of space transportation, but at the other side, it puts our position in a certain way at stake, and we have to reinvent ourselves. But we are not coming from nowhere, and we'll say a word on that. We have the new space economy, which is booming in all directions and in all sectors. No need to explain this further, but I give you just one figure. 2021, 145 launches at worldwide level, 14 out of that on micro-launchers, 10%. 10 in the US, 4 in China. So the question is now, when comes the European one? And we have a number of initiatives on that. We have a context where we have also some regulatory, I would say, boundary condition, and this will further increase with ITAR in particular. And last element, the human space exploration dimension is certainly also a game changer here. And let me just show you a short table. This is a table I have done at the beginning of this year, and I had to strike through a few dates because it's showing what are the human-rated capabilities across this small blue planet. And you see everywhere there are actors. Everywhere. I just look where the European flag is here. And this is something we have to reflect about. So for sure, some dates are changing. For sure, some services will come a bit later. But they are coming. And you see the US, you see China, you see Russia, you see India. And the key question will be, where is Europe in this context? And I'm looking forward to a space summit, which our Director General has prepared with heads of governments earlier this year, and we will have a space summit in 2023, where Europe will also have to take a position on such a topic. So these are all game changers. Then we had another element of context, which is, of course, also striking through all the initial plans. It is clear that since the 24th of February, the world is looking different in Europe. The world is looking different at worldwide level. What is the impact? We sent back within a few hours all the Russian teams exploiting Soyuz from our European spaceport in French Guiana. This was done immediately, but we had also planned 5 missions, 5 European missions on this launcher on which we have now to find solutions. And we will have to go from a Russian launcher on some missions to a US launcher. We decided this at the ESA Council last week. We have also, for one Russian launch, we'll go to a European launch. This was also a very good news from last week, and I'm looking to Simonetta, who of course is one of the biggest customer of our European launch services with Vega C in particular. And I think that's really good news. It's good to speak after Simonetta, because then you see all what is ahead of us in terms of launch services to provide. And an additional element is that we work on Vega C on the 4th stage with a Ukrainian company, which you may know. And of course, this is a point on which we have also to de-risk our program, and we are working now on solutions for European institutional missions, but of course also on European technology to ensure autonomy. I think this notion of technological autonomy takes a totally different and additional dimension today with regard to what we have discussed a couple of months ago. So once you have said that, what are the challenges for Europe? They are twofold. We have 2 key challenges to overcome. On the one side, we have to ensure our freedom of action. We have to ensure the European freedom of action as a critical enabler to deploy our programs. It's very simple. No launcher, no space program, no data to the citizen. So let's bring all the nice plans from Simonetta and colleagues, by the way, into orbit and not leave them in a museum. Second point, the pace of innovation is totally changing. And we have to integrate this in Europe. We are good in Europe. We have talents. We have know-how. But in terms of decision-making, we can do better. So let's think how we can take more rapid decisions when it comes to decisions of new programs. And let's also think how we can be faster in the implementation of such programs. These are, for me, 2 key challenges where Europe has really to reposition itself with a direct impact on space transportation. And it is clear that we will have to tackle this. So what are the transformation drivers? There are a number of them. You all certainly read the ESA Agenda 2025, where a number of elements are reflected here on how we should develop the sector in Europe. We have, of course, the European Green Deal, which is a boundary element which we fully integrate, and we have to go in space transportation over the whole value chain towards real green technologies on the one side, and to reduce significantly the carbon footprint, not only on the launch vehicle, about the whole life cycle. It starts with the raw material, it goes with manufacturing, of course also with the launch, but it makes only 3% of the overall emissions. And we have to do it also on the ground infrastructure. We want to have more investments, and I think at ESA we have a number of initiatives on that across the programs. We have an additional program, and I'm sure Géraldine will say a word about the additional efforts the agency is deploying on this. We have to deploy this with you. We have to do this with industry. It's only we will only have the effect in the result if we join the forces between industry and the public sector, of course, being our member states together with ESA, and I would say everybody in Europe should really contribute to this because this can and make a difference. Then in space transportation, I just would like to underline one important point. It's the rapid demonstrations. And this is where, when I said that now Poland can ignite the second stage, rapid demonstrators. When you mature a technology, when you bring it to a product, let's allow to test it. Let's test it in a hardware-rich approach. Let's test it rapidly. Let's test it continuously and then bring it to the market. So what I want to say, technology maturation is good, but it's not sufficient. You must have a target application and you have to go there fast. And this is how we will, in the future, also position key European contributions, industrially speaking, beyond European programs on the accessible worldwide market as well. I spoke about commercialization and human exploration as well. So when it comes to our repositioning on the European side, let's not forget from where we come, because we are not starting on a green field. We have launched last year at the Christmas Day the space telescope James Webb for NASA, and we have launched it with Ariane 5. It is a telescope which is worth more than $10 billion. Let's recall that. The fact that the US administration and NASA in particular put this in the hand of Europe, there was a number of reasons when the decision had to be made, also linked to the reliability of Ariane 5 in these days, with the volume and the fairing. But at the end, that they stayed with all the delays on the European launcher is a sign of trust. And the fact that we have delivered it with an accuracy to double the lifetime of the telescope was the best proof to our American friends that Europe is there, Europe is delivering, and this is certainly also an impact on transatlantic relations in the future. Second aspect, Vega C. Vega C inaugural flight took place on the 13th of July, 1313 UTC. This I will never forget in my whole life, you can imagine, to qualify Vega C. But I underline it because we are opening a new chapter. We are opening a new chapter of space transportation in Europe, which is based on Vega C, on Ariane 62-64. The first engine is common, the P120C, so we validated with that also one engine of Ariane 6, and now we deploy all the effort to have it as soon as possible. Next to a number of initiatives also around micro-launchers in Europe, next to a number of activities also linked to sounding rockets. I mentioned this in particular because I had very good exchanges with Polish industry this morning, especially around the topic of propulsion. So the rationale for 2030 is very simple and straight to the point. We want to develop a new model on transport to space, accessing space, transport in space, coming back on Earth, return to Earth, based really on services, not on systems, but on services, with a new way of cooperating between the public and the private sector, serving once again, on the one side, Europe's freedom of action, but on the other side, also to bring innovative, growing, and competitive elements to the market, and with that strengthen the European industrial sector and space overall. Step number one is in a few weeks from now at the Ministerial in Paris, end of November, and we based our proposal basically on 4 pillars. The 4 pillars do not have the same impact in terms of amount, because it's clear that T1 is now the market introduction of Vega C and Ariane 6. This requires quite a level of investment. To be clear, it makes more than 50% of our budget corridor overall, pillar number 1. But equally, and this is objective number 2, we need to prepare in an ambitious way the future, and this we do through a number of lines, and here the technological potential and the industrial and research potential of Poland is absolutely crucial through the future launcher preparatory program. Once again, around propulsion, around green propulsion, around throttable propulsion, but also other topics like robotic activities. By the way, robotic activities go beyond space transportation. They are really multi-program, and that's another very important point. Let's go to products which are multi-program. Then the Space Rider vehicle, we would like to go to the completion, to flight model number 1, but then to refly it and to demonstrate with that the operational capability of reusability. And last but not least, let's not forget, we need a European spaceport. This European spaceport is located in French Guiana for a number of very good reasons. It's located at an ideal place. We have invested a lot into that. We must make out of it a spaceport of the 21st century. Next to that, I would like to say it straight away. I'm quite positive and looking forward to a number of commercial spaceport activities across Europe. That's important as well. But we have to capitalize and invest on our spine, and the spine in terms of spaceport is clearly CSG in French Guiana. Next slide is that the how is important, and I'm sure that my colleagues will also elaborate a bit more on that, because I tend to say that I prefer to speak about the what, because this is what is our DNA, what we speak about day to day. But if we really want to meet the challenge, we have to address the how as well. We have to equally address the how we run a competitive procurement, how we give a fair chance also to new entrants, a fair chance, how we want to manage co-funding, how we want to have this incremental testing, learning on the go, and to be in a position also to adapt the way you implement the program without changing the rules. The rules of the game have to be fixed from the very beginning, but you have to inject also what you learn on the go in the implementation of a program. I will not go more into detail, but the how we run programs is, in my view, a key point for CM22, but also for CM25. Preparing the future, it is clear, and I just put this here in a symbolic way, we have to be able to bring back first stages, and maybe we can do it smarter than on the picture bottom left. Let's imagine that, and let's work on it. And I had also this morning with one industrial representative from Polish industry a very interesting discussion about this. And I really look forward to develop these concepts more. This is what we have to analyze and study more. The feasibility check, of course, has to be done. But we need to advance on reusability. We need to go also the step of a technological demonstration of a second stage reusability. Then the question of the business case. Let me be straight. This is not a point for the public sector. That's not the point for ESA. I mean, industry will decide if you take up this in a business case or not. But what we have to demonstrate that we can do it. And as mentioned, I think that the human space transportation aspect will certainly be a game changer if decided accordingly at the summit in 23. This is my last slide. That's a good news, but I really would like to underline, we have a forward strategy. We know where we want to go. We have a clear view. We have to bring the European actors together in their diversity. And once again, diversity is a richness. Competition is a richness. But what we have to be unified is about the key objectives. And these are, for me, these four here. First, of course, it's about the sovereignty of Europe. So autonomy, of course, is absolutely crucial. No need to underline this. The second point, and I go to the bottom right here, cost efficiency, because sovereignty and cost efficiency were also the drivers of our previous decisions. And this we will have to continue. Cost efficiency is a standard, I should say, standard operation procedure to have this in our programs. But, and now comes a very important point, we have an ambition for space at the Horizon 2030. I saw a big ambition in one domain, Earth observation, and telecommunication will come with a big ambition, and a number of other actors. I mean, we are at the service of these programs. So we need also to have a certain flexibility. We need scalability of our services, meaning if all comes, excellent, then we shall be robust and have a good model to cope with that. But if, for a reason or another, we have to adapt the ambition at the Horizon 2030, we need a scalable model. And this is really a key topic as well. And the last element, I just mentioned it, the environmental sustainability, the whole life cycle is absolutely essential on the ground and on the vehicle side. I would like to conclude by once again thanking and congratulating Poland at the same time. I really ask you to ignite now the second stage, because you are really there. Let's go to products, let's go to multiple program application, because at the end, it's how you get a return and value in your country. Thank you very much.
Bardzo dziękuję. Szanowni Państwo, teraz czas na to, żeby przetransportować tematyki transportu kosmicznego w stronę nauki. Zapraszam zatem na scenę Fabio Favata z dyrekcji ESA do spraw nauki.
ESA Space Science Director RAID.
Thank you and good afternoon. It's a great pleasure to be here and to celebrate together with Polish colleagues 10 years of Poland in ESA and 10 years of Poland in the science program. The science program is a bit of a very special element of the agency because it's effectively the only mandatory program in the agency. It's the only program to which all member states participate by virtue of their being members in ESA. Therefore, Poland has been in the science program since the very entrance, since the very inception of its membership in ESA. And I must say that it has done really a great job as a member state. And the science program, we support really a wide variety of missions, and we allow, through membership in the science program, each member state to realize together things that none of them, no member state individually, could possibly do on their own. And you see on this slide the numerous locations in the solar system that we in Europe uniquely have visited. As you can see, we've really been covering the solar system from its innermost corners with missions like solar orbiters that are literally skimming the sun, being roasted in the neighborhood of the sun, all the way to the outer planets, to places like Saturn, where, as I will show in a second, we have landed for the first time the farthest reaches in the solar system where Europe has actually landed. And same consideration applies to the observation of the cosmos, of the universe, where ESA science program missions have really addressed all parts of the universe and explored all parts of the electromagnetic spectrum, from the hardest gamma rays with missions like Integral, all the way to the microwaves with missions like Planck. And we are pioneering a new domain in astrophysics, which is what you can see on your right-hand side, gravitational waves. It will be the first space agency to actually fly a gravitational wave mission. But let me briefly cover how is our program structured. We have, as you know, again, it's a mandatory program, so the budget is decided by all member states at unanimity. Next decision will be, of course, at the upcoming ministerial a few weeks from now in Paris. Our budget is of order 560 million per year, which is, of course, a significant amount of money, but if you compare it with some of the, let's say, worldwide leaders, it's certainly a fairly small amount. And I would say with this amount, we are actually doing very well. I think we can say with pride that we are the most efficient science program in the world. One thing which is important and which I will cover in the rest is that each and every of our mission is a partnership with the member states. There are no science program only mission. The payload of all the missions is supplied by the member states, is nationally funded. Your scientists are the ones leading it. And Poland has played a key role in many missions. And I'm really pleased to say how strongly the Polish involvement in new missions is increasing, with the Polish role becoming more and more relevant in each mission. So really, the program, as I'm writing in the last line, is there to realize the ambitions that no member states, not even our biggest ones, can realize by themselves. The Polish stakeholders for the science program, of course, cover both the scientific community, and you have a very active, very strong scientific community, which predates ESA, active in a number of areas, but also it's not only related to space science, it's related to astrophysics and planetary science in general. The very significant interest in projects are based in Poland, not only for space, but also for ground-based astronomy, such as OGLE, which I'm mentioning here. And there is certainly a landscape which is both solid and growing for the elements that are of interest for the science program and for the space sector in general, with an increasing number of smaller players, which are very interesting in terms of our ideas for the future. Now, let me remember together some of the great things that we've done in the past before looking at the future. Already almost 20 years ago, ESA, Europe, landed on the farthest place in the solar system ever, Titan, with the Huygens probe. We landed on Titan, and of course everybody talks about the difficulty, the challenge of landing on Mars, but you know, Saturn and Titan are 50 times on average farther away than Mars is. And this is perhaps a little remembered. We should boast more about it. We should have advertised more feat that Europe has achieved. It was a fully successful landing, no issues, historical one, a memorable one, and still unequaled. We flew the largest monolithic space telescope ever with the Herschel mission in 2009. The 3.5-meter diameter silicon carbide mirror is still the largest monolithic mirror ever flown. The Space Telescope JWST that Daniel has mentioned shortly before in his talk is of course larger, but it's a segmented mirror. So this is another European first in which in the payload, by the way, Poland, CMB was, CBK was involved, as it was already mentioned this morning. So you can see the involvement of Poland in the European space science missions dates to well before the accession to ESA. Another amazing first for Europe was the Rosetta mission with the Philae probe. Again, a unique European feat, the only space agency in the world that has a rendezvous with a comet. I hesitate to call it a landing because the gravity of the comet is so negligible. They are really rendezvous and docking in space. It's not in any way a formal landing. And this, again, has been unique. And I know our American colleagues like to do things differently. They like to, ram into things, emboss them, and destroy them. We in Europe are more delicate and subtle. We dock onto them and study them from nearby. Once more, this mission hosted another element of Polish technology, a specific element of the payload on the Philae lander, again recalled this morning from the president of CBK. Today, we are flying a beautiful mission which is called Solar Orbiter, another European first, the mission that has flown closer to the sun and taken pictures of it ever, returning, as we speak, quite amazing pictures of the surface of the sun, which are fostering our understanding of it. And again, this carries Polish elements, electronics and other parts of a key element, which is the X-ray telescope called STIX, again under the leadership of CBK. So as you can see, it's difficult to find one of our science missions where Poland has not already had a role. We'll be doing another first, which is the exploration of the icy moons of our giant planets in the solar system. And why is this relevant? Because I frankly think that's the only place in the solar system that it can be hosting life today. Talking about Mars is very sexy, but let's face it, Mars is a desert, and if there is any trace of life, it's going to be fossil life. It's very unlikely that you have today life on Mars. If there is life in the solar system, it's in an ocean, and those moons host oceans under their icy crust. And they've been observed fleetingly from previous probes. They've been flying by, but a flyby is literally minutes, hours at best when it's very slow. JUICE will actually orbit one of those moons, will stay very close to it, 50 kilometers orbit for a long time, allowing us to study from nearby in an unprecedented way. Once more, there'll be elements of Polish hardware, of Polish instruments carried on it that will play a key role. And finally, Poland is taking a key role in our upcoming mission, another European first, the first time we have a dedicated mission to study the chemistry of planets outside our solar system. Once more, a big theme, is there life elsewhere? Well, you need to know what the chemical composition is of other worlds. Ariel will study it, and is the first mission ever. We'll study hundreds, perhaps thousands of such planets. And rather than elements of a payload, this will carry a full-blown Polish instrument, the FGS, once more developed by CBK. That's the first time that we have a full-blown, complete Polish instrument on the mission. And there is also significant Polish industrial involvement on the mission. So you can see a growing sequence of involvement, of role played by Polish actors in our missions. We are now flying also a new category of missions. We call them flexi missions, smaller missions, and there is another European first, which is called Comet Interceptor, the first time that we'll actually go and approach a pristine comet in the Sun, first time that it will enter the Sun. So with Rosetta, we've been studying from nearby a comet which had been orbiting the Sun already a number of times. Comet Interceptor will be parked in L2 waiting for a new unknown, never seen before comet to appear, and we'll go and meet with it. And it carries, once more, a complete Polish instrument, the dust-filled plasma instrument. Once more, growing involvement, growing skills, growing challenges. And once more, with significant industrial involvement on the mission. The next big step in our program is a mission called LISA. And LISA, once more, another amazing European first. I mentioned it very briefly, very in passing before, is a mission that will for the first time, study gravitational wave sources. And why is this key? Because those are the most energetic phenomena in the universe. And fundamental physics is no longer studied on Earth in labs. It's studied by looking at the universe. It's studied by looking up, by looking at astrophysical sources. LISA will be the first time that we do it. We plan to start the mission at the end of next year, and there are great opportunities for Polish scientists and for Polish industries that this morning I've had the pleasure to meet with a number of stakeholders in Poland to describe what those opportunities will be and how they can be shaped and how we should work together toward them. So if I look back at 10 years of Polish involvement of Poland in the ESA science program, Poland has gone really at an amazing speed from being a new member state to being a full-fledged player in the program. And that's really something that we have not observed very often. So there is a very high level, an increase in scientific involvement, which we see really with great pleasure. And there is really, excuse me, Poland is really leading now key scientific instruments, and we'll really look forward to do this in the future with increasing industrial involvement. Prodex is a very specific case in point. Prodex is a very specific tool, is a tool that is specifically designed for Poland, for countries like Poland to design hardware, is specifically designed for countries like Poland to provide hardware to the missions. All the instruments that you've seen are provided through Prodex, and we really would like to continue to expand the use of Prodex, to increase Prodex as a tool for you to progress. So how will we celebrate the 20 years of Poland in this science program 10 years from now? Well, as I mentioned before, we have a new class of missions which are small, which are led nationally in terms of their payload. Cheops has been the first one. That's a mission that has been led by Switzerland in the provision of the payload and scientifically. Great success flying now. We are proposing to the SPC Science Program Committee next week a mission called Arrakis to be led by Spain. And what I would like to, what we discussed this morning with the president of the Polish Space Agency and with other actors is that it would be great if the next mission of this class could be led by Poland, could be a Polish-led mission. And so my suggestion here today, let's work jointly together to make such dream true and to make sure that in 10 years we will celebrate, or whoever be in our place will celebrate 20 years of Poland and the science program using this tool. Thank you very much.
Dziękuję bardzo za podróż przez misje naukowe, a także za zachętę do budowy polskiej misji, małej misji kosmicznej. Proszę Państwa, czas na Geraldine Naza, dyrektor ESA do spraw komercjalizacji, przemysłu i zamówień. Zapraszam na scenę.
Industry and Procurement Director.
Dzień dobry, and may I also share a few private, or let's say, remembrance of Poland. I had the pleasure to be there at the first review of the transition period of Poland. It was 2015. And for those who were there as well, we had two directors general of ESA. I think it was the first time I saw two directors general, the one who was finishing his mandate and the one who was arriving the next month. So it was almost my first mission as my new post in industrial policy. So I have a very strong memory also of the work that we did in the years after with Stefan and colleagues. And I think today we are here to celebrate indeed these 10 years of Poland at ESA. And I think, yes, in 10 years, lots has been done. It's quite amazing. It is clear that an industry has been strengthened, as Simonetta has pointed out, numerous successes in Earth observation applications, good integration within the supply chain of European industry, excellent SMEs. You know, in the industrial policy, we also take particular care of SMEs, and we are very happy with Polish SMEs and R&D capacities. But like Daniel has said, this is the start. This is the first stage. I'm also a rocket engineer, so let's go for the second stage. And I think the second stage will require even more investment. And by the way, I think it is important for all of us, because what we have seen with space in the last years is that public investment is key for fostering, for stimulating private investment. We have seen that in the US, and I'm convinced we shall see it in Europe as well. So where are we? Yes, this is a new space age, but let me first say something to my big horror. There is a dot missing here. It's not 802 billions, it's 80.2 billions. Unfortunately, I have to say, I would like the public space investment to be 800 billion. It will probably come, but not today. So for the time being, it's 80.2. I will send a revised version of the slides. I don't want to give false hopes. But it is still a very important figure. 80 billion of investment, public investment worldwide, and with Europe, which represents more or less 15%, so 12 billion public investment in space for Europe. But what we see next to it is that there is also a much growing private investment in space. We are today in 21. In 21, there were 13 billion private investment in space worldwide. We expect that this year this will grow significantly. And as concerns Europe, in 2021, private investment was 600 million. We expect more than 1 billion in 22. So, as you see, almost doubling the private investment in space in Europe. And this is excellent news, but as I said, we must be careful that the private investment in space is closely linked to the public investment in space. We know that the success of SpaceX has been fueled by NASA contracts. So I think space agencies, governments have a role to play in ensuring that this private investment also occurs in Europe. Another game changer for space, and why we say we are in a new space age, is the number of launches. Last year, more than 1,800 satellites were launched, and this is a multiplication, a very rapid multiplication by a factor of 4 in just 2 years. And there again, it is continuing. And out of all these satellites launched, 95% were small satellites, below 500 kilograms, also there, a game changer. And I think Europe is starting to understand that this indeed, as was said before, this might be a challenge. This is mostly, for us, an opportunity. Because we are indeed entering a new space economy. Launch costs, they should be further divided, probably by a factor of 3 in the next decade. They have already been considerably lowered. And this is good because the lower the launch costs, of course, the higher the number of opportunities for space to be used as a tool. It has been said many times, when we have very high launch costs, this restricts the use of space as a tool, but there we can see a very good trend. And also, payload capacity is increasing. The payload is much more efficient, so we can either have smaller satellites for an equivalent service or more powerful satellites for an equivalent mass. There again, a factor to increase the use of space. But why should we increase the use of space? It's quite simple. Space is useful. Space is a tool for all our policies. And of course, we dream in front of the beautiful pictures and perspectives for science in space, which, by the way, science beside the, let's say, the pure value of science, and we are here in a country which knows the value of science, beneath this value there is also the fact that the scientific progress is the technology of tomorrow and the applications of the day after tomorrow. It is essential also science as a stimulus to develop completely new technologies which will eventually lead possibly to some applications. So this is an important factor, and we see, for instance, that deep tech, the very advanced technology of today, already gets into space infrastructure, both on the space and the ground segments, such as edge computing or artificial intelligence. Space as a service is also a new approach to space. I think Daniel was also identifying it, because now, most often, we will not procure infrastructure, we will procure services. When I say we, it's not necessarily ESA, but those users of space, they are not interested in buying an infrastructure. What they want is to buy a service. Of course, this is already well known to certain sectors of space, but this will be increasingly the case. Green and electric propulsion, you mentioned it as well, Daniel. It is clear that, as Simonetta has shown, ESA is at the edge, is a leader in environmental monitoring. We have shown the way. We are really ahead of all other space powers when it comes to monitoring the environment, understanding the climate, and possibly in the future even enforcing some environmental regulations. I believe that we have no choice as a space agency than to also be environmentally conscious. We cannot promote so much the monitoring of climate and environment and ourselves in our own activities not be in line with environmental concerns. So this will be something we will have to do, by the way, not only for environment on Earth, but also for the space environment. And we are very active in that, in limiting the number of debris, in reflecting on how to remove debris, and ensuring a clean, let's say, space environment. And finally, last but not least, what we see also in this new space economy is a completely new and emerging markets. In-orbit services, but not only, but I believe that in-orbit services will be a very significant emerging market for space, with many applications, such as servicing satellites in orbit, extending their lifetime, inspecting them, possibly refueling them, repairing them. There are many applications of in-orbit servicing, and possibly even in the future, manufacturing in space and assembly of very large structures. So we are really watching the beginnings of this new space economy. And what is ESA going to do about it? Clearly, ESA has a role to play because, as I mentioned, I believe that the public investments are the foundations for the private investments. And the many investors that we meet tell us, yes, that if you are interested in a given domain, in a given technology, in a given activity, then for us, it's a stamp of confidence, and we are more ready to invest in space than in those cases. So we have this role as well. And when it comes to what we should do, our ambition is to make Europe a space commercialization hub, to grow, to develop space companies that make sense for our future. And I insist on the last part of the sentence. Once again, we don't do space just because it's nice and beautiful, just because a few rich men across the Atlantic do it. We do it because it's useful, and it's more than useful. It's irreplaceable for ensuring a good future for our society and for our planet. And what I want to also emphasize is that clearly, even if the Director General of ESA has identified commercialization as a key priority, it is not new in ESA. We have been doing commercial activities, or let's say commercially related activities, for a long time, indeed. The Directorate of Elodie, Telecommunications and Integrated Applications, is mostly about commercially related activities. Also in Earth observation, we have, as mentioned by Simonetta, commercially related activities such as InCubed, but also others. In launchers, we have Boost. In almost all the directorates, we have commercially related activities. More than 2 billion euros of ESA yearly budget is actually linked to commercially related activities. But what we are missing is a kind of a cement, a glue among these activities, a coherent approach, a corporate approach to support all these commercially related activities. And that's what the Director General has wanted to create by creating this new directorate with a commercialization department in it, to provide services to complement the existing activities in the program directorates by a series of services helping these activities. And I will now say a few words on that. And this is the goal of the program that we will present to the ministers in less than 1 month from now in the Ministerial Council in Paris. It is a small program, Scale Up. It's composed of 2 elements, one called Invest and Innovate, and one called Innovate. I will come more in detail to these elements. And it's a small program aiming at providing end-to-end services. The 2 elements, Innovate and Invest, are really linked to the entire life cycle from ideation, from the first idea to getting on the market. Because to get to the market, if you have an idea, first of all, you have to have an investment in innovation. You have to, we as an agency, we have to invest in brains, in innovation. Then we have to provide support, technical support, business support, perhaps some in-orbit demonstration opportunities, and then we have also to provide access to funding. And finally, we have to support the readiness on the market, and all that we have to do fast, because this was said. What we are missing at ESA now, and what we have to provide, is new ways of procuring, new ways of getting quickly on the market, being more agile, in short. We are a very successful space agency. We've been doing very good things, superb activities, actually, over the last 5 decades. But now is a new age where actors are expecting us to be much faster, and we will. I will just say a few words indeed on these 2 elements. So, as I mentioned, the first element is Innovate. It is about really investing in innovation through a series of things. I will come to that. The second one is Invest. So let's go to the Innovate element. First, and I would like to spend a few minutes on this one, first I would say we have the incubation. Let's say you are a young engineer, scientist, you have an idea, you want to start your business, you will need to be incubated, you will need to get some seed funding to promote and to grow this idea, develop this idea. So at ESA, we have a network of business incubation centers, and it's my joy today to tell you that tomorrow, the 26th Business Incubation Center of ESA will be signed. It is the Polish Business Incubation Center, and I'm very happy to say it will be signed tomorrow by our Director General here in Warsaw. And this Business Incubation Center, Poland, will be in 2 locations, actually, Warsaw and Rzeszów. I'm not sure. and with the goal of having 35 startups incubated over 5 years, so 7 startups per year incubated, that is the goal, 5 in Warsaw, 2 in Rzeszów. And also I want to indicate to you that these business incubation center, which was initially discussed and funded through ARTES, will now be moved to scale up for its continuation and expansion. And as you can see, the business incubation centers provide a series of support and services, starting with incubation management, of course, providing training, providing promotion, organizing workshops, also providing the seed funding through a startup incentive fund, providing technical support. This is very important, that we as a space agency can provide the technical support to these startups, respond to their questions, and also make sure that they are working closely with us, because I'm convinced that ESA can benefit from the innovation and dynamism of the startups. And finally, also boost funding, so this is even more funding for those startups which require a little bit more funding, and pre- and post-incubation services. So, welcome to Poland in the network of ESA business incubation centers. Just to tell you, this is a very good investment that you are making with the BICs. Just to give you a few figures, overall at ESA, this big network has already incubated or is incubating more than 1,200 startups in just 20 years. Providing these startups achieving a revenue of some 165 million euros. Having raised funding, each of these startups, having raised a total funding for all the startups of 434 million euros, and representing in total 3,760 full-time equivalent jobs. So the investment in the BICs is a very good investment. Next to the BICs, and I would say almost in complement to the BICs, because it is equally important for the BICs, is what we do in terms of technology transfer. This is composed of 4 main activities. First of all, technology brokers, bringing space technology to non-space, but also possibly bringing non-space technology to space, so making sure that there can be spin-in and spin-offs between both. Spark funding is also an element of the technology transfer to accelerate commercialization and being on the market. A very important point is intellectual property. Intellectual property for commercialization, because for a startup, the idea is the only wealth of the startup. Usually a startup has nothing else than brains, 1 or 2 or 3. The ideas have to be protected. But also, we have to promote the commercialization of these ideas once they have been protected through the appropriate intellectual property tools. So this is an important factor. And last but not least, prepare for space, prepare for ESA, and ensuring that the startups can work within ESA activities. Another important point of this Innovate element is the PhilHub network. Simonetta has presented the PhilHub, the initial PhilHub, the mother of all PhilHubs, shall we say, which is hosted at ESRIN, and it's mostly dedicated, but not only to Earth observation. And following the great success of this PhilHub, many countries, including Poland, have now developed ideas for national PhilHubs hosted in their home countries. I can tell you that the Poznan University of Technology has made a proposal accordingly. It's dedicated to operations in space, in-orbit servicing, as I mentioned, on-board processing as well. It is a very relevant idea. And on top, I believe the idea of this PhilHub is also benefiting to non-space industry through many sectors. So this is a very important thing, and I look forward to developing this PhilHub network together with my colleagues. Going quickly to the invest element, which is the next step. Once you have been incubated, you have a protected intellectual property, you are growing, comes the time when you want to accelerate, further grow, and there you need access to investment. And that is what we are doing, firstly, by setting up this investor network with the colleagues of the Commission, EUSPA, European Investment Bank, and European Innovation Council. One element is the marketplace. And I would like to say something and conclude that on the marketplace. Eventually, once you have the very promising startups which have grown, which have gone to acceleration phase, which have which have been accessing private investment, comes the need to enter the market. And we believe that a space agency can also help supporting the new markets. And to that effect, we shall put together a marketplace. We shall put together a marketplace for new and emerging markets. So, first of all, we will make open calls using a mechanism which is called the OSIP platform, set up by our colleagues from the Technical Center, ESTEC, where we will get the proposals for new markets, new offers, but also new demands, and assess the credibility of these offers. And based on that, and based also on the co-funding by participating states, we shall thus help to grow these markets and bring in contact, make sure that the offer and the demand can be matched. And I believe this is also a good way to prepare for sustainable markets, because these new markets, obviously, they have to be built. They are just at the beginning. We have to help them, and we at ESA, we have the very good position to do that, because we are exactly between the offer and the demand. So with all these, I see that also seeing the very promising ecosystem of space in Poland with, as I said, very dynamic SMEs, excellent R&D capabilities, I believe that Poland will be best placed for really entering this new space age and entering this space commercialization era. Thank you.
Bardzo dziękuję. Zapraszam na ostatnie wystąpienie przed przerwą. Zapraszam na scenę Elodie Lee, dyrektor ESA do spraw telekomunikacji i zintegrowanych aplikacji.
ESA Director for Telecommunications and Integrated Applications.
Hi everyone, thank you. It's a pleasure to be with you here today. So I'm Elodie Vieux, I'm the Director for Telecommunication and Integrated Application. I was joining this morning just listening to the industry panel, and I was astonished and very impressed by a few comments out of them that were already mentioning a lot of activity, a lot of development done with ESA and through the Telecommunication and Integrated Application Program ARTEST. I will show you a few examples and give you visibility on what we are proposing next. Yeah, as we say, space is accelerating, and the telecom and the integrated application is one field where it is as well as accelerating. We have heard this morning from one of the panelists that was from the industry, saying that 12 years ago he has started and he was turning up the light with ESA. And what we want to do is turn up many more light with you when we have more businesses, as we have heard Geraldine, that there is an importance of commercialization and industry and economical benefit of the space that is now getting closer to Earth for many applications. So going very quickly, application from space for the user on Earth. This is about connectivity. This is what we are. We are today. You are using digital data. You are connected every day. And this is for, as you see on this picture, for the benefit of the society. So yes, we are doing space because it's cool and it's fun. But we are doing it, as Geraldine said, because it's providing benefit on Earth to our society. And this is how we will bring solution to the many crises that we are facing. Facing crises on the health sector, like the COVID, where we needed to be connected while being, unfortunately, isolated from each other. facing crises like the Ukraine war that is just at the door of Europe, when we need to really have more autonomy and sovereign system in telecommunication in order to be able to communicate in those difficult times. Also, during an energy crisis that is coming up, how do we secure and have connectivity and be able to monitor our energy distribution system to optimize them? So that you can see on this picture, yes, it's for the future for our kids. This is for the future of a digital economy in which we are. And you will see that this global satellite industry is having a strong role to play in this digital economy. We have more than 200 billion of global revenue that is coming from the commercial space economy. And you see that the infrastructure, the launch and satellite manufacturer, launcher that was presented by Daniel, and the satellite manufacturing that Simonetta was mentioning, that ESA is some of them manufacturing, building satellite. This is also generating satellite services. And those services are mainly driven by telecommunication application nowadays. The total space economy is also growing. As you can see, and as Geraldine was highlighting, there is more and more also investment and private investment coming into the space economy. The SATCOM market, let's say a word about the SATCOM market. So what is very key in this slide, which is quite busy, is showing a growth of demand on market consumption. So we are consuming more and more data, and those data need to be provided, and space is one way of a distribution. And this SATCOM market is now getting more and more completely seamlessly integrated with the terrestrial market. So space is becoming a way of getting the information safely, securely, and at speed. So when the time matters during those crises, but also during our daily life when we want to have high data, high throughput applications, that's where we need the SATCOM market. And you can see there is a cost challenges. So we need to become more and more cost efficient, because indeed the cost per megabits per year is actually decreasing. So the application need to become more and more cost efficient, which is a driver for the innovation that we are pushing together with the industry at the European Space Agency. So what we see, the data demand is growing, and the cost and the efficiency in providing this data is really decreasing. So now at the European Space Agency, yes, we have turned on many lights already with Poland, that I'm very pleased to be there for your anniversary of the 10 years, because we have a decade of success as well in the telecom. And you can see on this slide that at first we were having a big satellite. And now, as Geraldine has mentioned, we are going towards small satellite as well. So we still have the big satellites that are providing geo-orbit connectivity, but we see a full population of smaller and even nano satellites that are affordable and then can do very fast in-orbit demonstration, very fast innovation cycle, while still providing a minimum of services. So connecting Europe globally, space is part of the solution. So for the government, and you will see when I present the upcoming program for the ministerial, we are also now in the telecommunication domain. We have the ambition of the European Commission to have a global, secure connectivity network. And therefore, we are also working together with the European Commission to do the development and validation in partnership with the industry of such a system. For citizens, because we have tomorrow 5G and very soon after 6G. And what does it bring? It brings connectivity not only on the physical world for 5G, that is machine-to-machine connectivity, that is accelerating the path of the data throughput that we are using in the daily life in smart cities. But it's also going to work 6G, where we are going to integrate the virtual world and the physical world. So I will not go too much in detail of the metaverse and how this new way of spending some time in the virtual world with some experience will require a significant amount of data transfer and connectivity. And finally, as you see, we are touching the non-space sector. We are seeing now, there were some announcements of having direct-to-mobile application using space directly. Having also the autonomous cars that are going to use the terrestrial network, but also the resilience network through space. So touching of the mobility, being now you take a flight and you have almost internet in all of those flights through satellite. Having also telemedicine, teleeducation, and as we mentioned, we are also going to see how those applications of telecom and integrated application through space are bringing the solution for decarbonization, which is a solution for the climate change. So I just will do a bit of focus on security and autonomy and resilience, because space is part of this solution. As I was mentioning, there is, as part of also the Poland strategy, the importance to develop secure system and autonomous system. And at the European Space Agency, we are working with the industry to facilitate the creation of those systems, to be resilient, to be autonomous, to have a say at the table is not to isolate ourselves, but to also connect securely across the globe using, for example, quantum key distribution. And to be resilient, having an integration of the space and the terrestrial network, it needs to be secure from the beginning to the end. So now what is our proposal for the ministerial, the upcoming ministerial? So in the telecom and integrated application at the European Space Agency, you know very well ARTES. It was mentioned by the industry many, many times, and I'm very honored and I'm very pleased to have the Polish industry very much active in ARTES, and I will show you with real fact and figure how much you are already part of it. And now, at this ministerial, we are presenting 3 new programs, which represent 50% more public support ask, which is, as Geraldine and Simonetta was mentioning, we need this public support to initiate, to turn up light, and then make the industry grow and be able to work without public support. So we have the first one, which is Secure Connectivity, which is the program where we are partnering with the European Commission to develop this global network. And I'm very pleased to say that we have the Polish industry that has answered to the preliminary market consultation. So yes, the Polish industry is already knowing this program and coming forward. There is also a program on civil security from space, which is a program that we are doing together with Simonetta of Earth Observation, which is about to provide the amount of data and the computing secured and trusted data at the security actors during the crisis, can be induced by the climate, as you see, or that can be induced by a geopolitical event. And this is really targeting civilian protection, civilian security. And then we have a program that we are doing together with the Navigation and the Human Robotic Exploration Directorate, which is Moonlight. And Moonlight is about bringing a telecommunication and navigation system around the moon, like we did in the past around the Earth. So for ARTES, so we are 3 main, let's say, motto in ARTES 4.0. First is to kickstart new and disruptive technologies, so it's about innovation. Then it's about meeting the public and the commercial need. So it's very much a program built to bring competitiveness of the industry in the domain of having the services and the first application deployed. And we are investing in the future of space. So this program is done in a co-funding scheme. meaning that we have the public and the private financing that get together to do more and to share the risk of the innovation step. In this program, we have 3 strategic program lines that echo very well the strategic priority of Poland. You have the space system for safety and security, which is about how to communicate encrypted data when we will have the computers that are quantum and that are able to decrypt faster the code. How do we use space? And space is fundamental because today, through terrestrial mid, if you were trying to do so, you will have to re-encrypt every 100 kilometers. That's why space has a fundamental role to play. Then we have quantum and optical, where also already we have the Polish industry that is participating. And then we have 5G, 6G for sustainable connectivity. And as you can see, we are going to propose programs and name of project with partner, where we will be able to not only develop application with the 5G, but we are already proposing 6G satellite to demonstrate the next generation of innovation and to propose some hub where the industry can come from a collaborative way to develop their application. Then the core competitiveness, it's a program where you can do a lot. It's a very flexible, agile program where you can develop equipment, where you can do in-orbit demonstration of a satellite, like the W-band satellite that was done. And I want to highlight that in this program, there were 36% increase of SME involvement between 2019 and 2022. So this is one of the biggest increase that we have in this program. We have an average of 6 customers that are already at the end of the program there for the new product that has been developed. And you can see that you have 61% of activity that are led to industry, to new customer. And then we have business application and space solutions, so where we are looking at the services. And this is the key topic of services developed: energy and utility, safety and security, but also health, agriculture, transport and logistics, and up to the environmental and wildlife. And then we have above 75% of SMEs and 40% of newcomers between 2019 and 2022. So this is where we are. And here is we have a special focus now on this program of business application and space solution to look at how we will be able to contribute to a greener future, to be able to answer how to reduce the decarbonization, to accelerate the decarbonization, to answer to the climate crisis. On the partnership project, which is more the satellite manufacturing, we have new program. So the Polish industry has been critical in NovSatcom 2 for software, for panel, but also for solar array, and has been accelerating the development, as we have seen. Now the satellites are software driven. So that's why those new projects will be an opportunity for the industry to do more with ESA. Now we're going to EU Secure Connectivity Program. So as I mentioned, it's a EU Secure Connectivity services that are targeted by the European Commission. So it's foreseen to be a multi-orbit system, LEO, GEO, MEO. We are partnering with the European Commission and the industry in order to do the development and validation. And we are going to leverage on our ARTES capability and know-how at the European Space Agency to be able to efficiently, the challenge is huge because the start of services are foreseen by the European Commission in 2024 with a full deployment that they are targeting by 2027, 2028. So the challenge is huge, but we have the competence in Europe. And this is very important because this program is to boost as well the European capability and autonomy. And on this program, which is in a way the next program after having Copernicus and Galileo, so this secure connectivity program, ESA is there for its expertise with the industry, partnering with the industry to do the development and the validation. And in a public-private partnership scheme that is currently foreseen, to be able, as I say, with a very aggressive schedule. On Moonlight, I will be very brief. However, the Poland industry is also manifesting interest, where it's developing, from a commercial perspective, communication and navigation around the moon in an approach where we will support to turn up the light of this future moon operator. And that's the ITT is in December. And then for civil security from space, as I said, done with the Earth observation colleague, with Simonetta. So as you know, we are facing a lot of challenges, and our European citizens are at stake for for crises that are induced by climate or for crises that are induced by the crisis. And so for that, we need to provide the means to the security actors to have the data, the secure data that are provided very quickly to them to be able to, in case of a fire, in case of a flood, be able to respond and minimize the impact on citizens and minimize the impact on the economy. So there is 22 responses that are under analyzed right now, and we will have an Industry Day 8th of November. We have also a dedicated Industry Day for Poland that will happen on the 3rd of November. And with that, I would like to thank you very much, congratulate Poland one more time for this 10 years anniversary. We have so much to turn on, so much more light with you, that I can only encourage you to contact us and to share your innovative idea with us. Thank you very much.
Dziękuję za wystąpienia licznej reprezentacji dyrektorów z Europejskiej Agencji Kosmicznej. Szanowni Państwo, teraz zapraszam na przerwę, po której spotykamy się za około pół godziny, by kontynuować rozmowę o wyzwaniach ESA na nowe czasy. I przypominam, że znaleźliśmy klucze. Jeśli ktoś z Państwa zagubił, proszę się zgłosić do nas. Dziękuję.
Czy wiesz, że inwestycje na badania kosmosu zwracają się jako rozwiązania, z których korzystasz na co dzień? Bezdotykowy termometr, zestaw słuchawkowy czy nawigacja w telefonie to przykłady niektórych z nich.
Brzmi kosmicznie? Sprawdź to.
Europe is at the heart of new space ambitions, ready to embrace ever greater technological and human challenges. The first objective is to maintain autonomous launch capabilities for our missions. Based on 50 years of experience in launchers, we can ensure space transportation for future missions. In orbit around our home planet Earth, the International Space Station continues to play an essential role as a research platform. Soon it will be possible to journey in the Orion service module to the Lunar Gateway, a station that will orbit the Moon and be the first deep space outpost supporting human exploration of the Moon. By the end of the decade, a European moon lander should deliver the cargo needed to survive the lunar night in a base camp, securing a European astronaut's presence on the Moon. But to secure our independence, shouldn't we find a way to get there ourselves? What if Europe were to develop its own crewed transport system? The Space Rider demonstrator is a step in that direction. Striking out beyond the Moon, we'll send the Sample Fetch rover to Mars to collect samples and bring them back to Earth, so scientists can unravel the mysteries of the Red Planet. Many other missions will be key to prepare for human exploration of our sister planet. Let's take part in those first steps. And why stop there? There's a natural satellite around Saturn named Enceladus, which may also harbor life. Isn't life the very essence of our planet? Together, let's explore space, traveling farther so as to come back with new knowledge to improve life on Earth.
Technologie kosmiczne wspierają nas w codziennym życiu. Dzięki obserwacjom satelitarnym możemy prognozować plony, przewidywać skalę powodzi, zasięg pożaru, a nawet monitorować stan naszej planety.
Brzmi kosmicznie? Sprawdź to!
Czy wiesz, że technologie kosmiczne pomagają nam dbać o zdrowie? Skanery medyczne, odporne na zarysowania szkło wykorzystywane w okularach, czy laserowa operacja oka? To tylko niektóre z przykładów.
Brzmi kosmicznie? Sprawdź to!
Technologie rozwijane przez sektor kosmiczny to nieodległa galaktyka. Obserwacje satelitarne mają bezpośredni wpływ na nasze bezpieczeństwo. Wspierają ratowników medycznych w niesieniu pomocy.
Brzmi kosmicznie? Sprawdź to!
Houston, Tranquility Base here. The Eagle has landed.
It's 60 years since humans first went into space. By using rockets and developing life support systems, we have learned to live and work in orbit around our planet. But we dream of exploring farther, to set up home on the moon and beyond. ESA selects astronauts from our member states to train for and complete our missions. To be an astronaut, you must be experienced in technical work and healthy enough to fly to space safely. Once selected, astronauts try to fly in space and to conduct a whole range of experiments there. Our astronauts train with partners agencies around the world, and particularly at ESA's Astronaut Center in Cologne, Germany. ESA conducts special studies on the ground to prepare for missions in space. Our home planet has extreme environments where we can train astronauts and test equipment. We work underground, in volcanic landscapes, and in isolation in the Antarctic. We test tools in rocky landscapes and create and store materials that resemble the surface of other planets. We also create elements of the space environment. We use bed rest and parabolic flight to test the effects of weightlessness, as well as Mars yards and lunar bases made with simulant dust. The International Space Station is one of the most amazing machines ever built. A huge international team worked together to make a laboratory where astronauts can run experiments to help life on Earth and our future lives in space. As well as doing their daily experiments, astronauts on the station need to be able to monitor their health and well-being and support their fellow crew members. They communicate with the ground regularly, including with flight controllers based in Europe. Some experiments and repair work on the space station require astronauts to go outside. They wear spacesuits to conduct extravehicular activity, also known as spacewalks. Spacewalks are rehearsed in detail, using deep swimming pools to simulate the weightless environment. Spacesuits are brilliant machines, like small spacecrafts in themselves. But we would like to make them smaller and easier to move around in, especially for walking on the Moon and Mars.
Drodzy Państwo, rozpoczynamy ostatnią część pierwszego dnia konferencji 10 lat Polski w ESA, wczoraj, dzisiaj i jutro, w trakcie której poznamy dodatkowe wyzwania, przed którymi stoi dziś Europejska Agencja Kosmiczna. Na scenie już jest Jorge Amador Monteverde z dyrekcji ESA do spraw operacji kosmicznych, którego prezentację za chwilę zobaczymy. Zapraszam.
Thank you. Do you hear me? Yeah? Okay. So my name is Jorge Amador Monteverde. I'm replacing Holger Krag, who is the program manager for space safety, but he couldn't come because he gave positive in COVID, so I hope he will recover soon. So I will present you a brief introduction to what the space safety program is for the period 2, what we are presenting for the ministerial in 1 month, and then the opportunities you may find in the program. So what is it about space safety? Space safety is about protecting the Earth and the infrastructure and humanity from hazards originated in space. They can be natural, like a geomagnetic storm or a mass ejection from the sun or an asteroid, or they can be man-made, like debris or operational satellites on a collision course to existing infrastructure. So with this in mind, the space safety goals for this period are in the 3 areas mainly: space weather, planetary defense, and clean space and space debris. In space weather, we really are going towards an early warning system tailored to European user needs. For asteroids and planetary defense, we really have 2 very clear requirements: to have early warning for asteroids bigger than 40 meters before 3 weeks in advance, and to have the capability to deflect asteroids which are smaller than half a kilometer 2 years before. An example of that is the HERA mission, which is complementary to the DART mission from NASA that was a success a few weeks ago. Apart of that, we are looking into establishing European players for a growing market in the space traffic technologies and products. This is a growing market. As we speak, there are more and more companies and more services being provided in the market. The problem is they are mostly coming from the US, so we are really trying to close the gap there. And we are preparing industry for a zero debris policy in what we want to have as a circular economy by 2050. The program started very small in 2009 with 50 million, and in 2019 we already have 450 million. Why this big increase? We have now not only observations, like in the first 3 periods, but we also have the risk analysis, mitigation, and remediation dimensions, meaning we have missions. Now for the ministerial coming next month, we are doubling the budget. We are asking for 910 million, and we are basically continuing what we started in the first period with the Vigil mission. I will briefly describe all these items to you in the next few slides. With HERA, the HERA mission, what we call COSMIC, which includes a number of core activities and small missions and projects, and the ADRIOS missions, including active debris removal 1 and a future in-orbit servicing mission. What about Vigil? Vigil is about space weather warnings. Vigil is a mission we started we are currently starting for phase BCD, and the objective is to give warnings on to the same way we have meteorological satellites around the Earth. We'll have this one, an operational satellite. Remember, this is not the scientific one, it's an operational one, providing warning on the space weather, on the weather coming from the sun 1 week in advance. So it will be located in the L5 point, so in the point which is forms an equilateral triangle between the sun and the Earth, on the orbit of the Earth, but on the back. And it's complementary to a NASA mission in L1, where it will be in situ. There will be in situ measurements. So these remote measurements will be combined with in situ ones, providing unprecedented operational performance. Then the HERA mission, the example of planetary defense, will complement the DART mission from NASA, you saw already a few weeks ago, and will arrive to the satellite. We will launch in 2024, and it will arrive to the asteroid in 2026, and will complete the full characterization of the dynamics, the materials, and everything we need to really have claim we can have the technology for deflections of asteroids posing a threat to the Earth. Then we have the ADRIOS mission, particularly called the ClearSpace mission, because it is the first mission of the ClearSpace company. It is a private-public partnership with co-funding from industry, and the objective is to grab a piece of ESA-owned debris, in this case the upper stage of a Vega rocket, and force a re-entry into the atmosphere. This is already running, and it was based on an unsolicited proposal from industry. We also have what we call zero debris approach, which we will have implemented in ESA as an example. This is the first step in what we hope will be a future regulation in Europe and in the world on zero debris, where we, by 2030, we want to be able to design and implement the really sustainable space systems, and be able also to have the technologies to remove these systems which were launched before having these capabilities from in-orbit due to in-orbit failures. By 2050, the objective is to really have a circular economy where at least 50% of what we build will be reused from the launch mass. More on ADRIOS. Another mission we are preparing right now is the in-orbit servicing. We made a call for proposals from ideas first, and then for proposals from companies where they would propose, together with a customer, the in-orbit servicing of a satellite owned by that customer. We have now 4 contracts, what we call in maturation phase. 3 of them offering life extension of GEO satellites in orbit, and 1 of them offering refueling of a LEO constellation. We are maturing these contracts, and we are proposing some budget for that, for a final mission in the ministerial, and once we have that budget, we will make an open ITT, and we will proceed with implementation of the mission. Then we have what we call COSMIC, which stands for Core Small Missions and Projects, including competitiveness. It includes what we used to have as core in the program: space weather, planetary defense, and space debris activities, and also clean space, but also adds a number of small missions to increment the number of sensors we have, and to really go support commercialization. I will go into more details. Of course, we have the core activities as in the past 13 years, and we have added what we call the competitiveness segment. In line with the overall ESA support to commercialization activities, there is a growing need in the space safety markets, and we are there to support the last mile of commercialization of space safety companies. Going just briefly through the missions. So the first mission is Aurora mission. It's a small satellite, in the other 100 kilos. The mission will be to monitor the Aurora Oval in order to warn for geomagnetic storms. There will be a demo mission proposed in period 2, and the idea is to have a constellation in the following periods. Then also in space weather, we are proposing a number of nanosats, operational space weather nanosats, where there will be we have already 5 parallel contracts with different objectives, and we will implement them in this period later on. The idea is to have, as you see in the image, a total space weather system, including big missions, smaller missions, nanosats, and also, why not, commercially provided nanosats. If we move to the planetary defense area, the basics, the 2 of the activities we are running is the continuation of the FlyEye telescope, a very complex 16 lenses telescope for the tracking of asteroids, and we are moving towards something a bit more commercial, what we call the telescope array, that will allow, it's the same concept with a totally different design. Also in planetary sorry, now we are moving to the space debris. Another small mission we are proposing is called Wisdoms, which is in situ debris optical monitoring from space. So instead of monitoring from the ground, which we have a number of technologies, both optical, radar, etc., we will do it from the orbits which are already congested. Initially, we want to have a hosted payload, but the idea is to, in the future, to propose a small mission by itself. Then the deorbiting kit, the idea here is, this is not a mission, but this is to really focusing on commercialization of these services and it's mostly focused on the launcher stages, but to launch this to attach to some a big piece of debris and force a re-entry. And this you can buy if you are developing a new satellite, for example. You can buy, the idea would be to buy a deorbiting kit to attach it as yet another payload to your satellite, so it is enacted at the time of the end of life of your satellite. And finally, it's important to recall, yeah, we have talked about big missions, small missions, and so on, but one of the key assets of the program is all this software and all these sensors we have developed over the years for space debris, for planetary defense, space weather. We will remain working on that, and the amount of debris is increasing by the day, and we really have to keep working on this, on the core software, on the technologies and operational services we have developed to keep growing on that. Last but not least, the competitiveness segment. Everything I mentioned up to now is defined by ESA. We define the requirements, we make procurements, industry participates and runs the activities. But in line with the commercialization activities of proposed the commercialization approach proposed by ESA, we are including this part in the program. We are not proposing activities here. It is industry proposing. There will be an open call for proposals, permanent call, in which we will evaluate these industry proposals, which have to come with formal support from the delegation. And we are there not to develop technology, like in other programs, like GSTP or InCubed. We are there to support industry in the business, in the last mile. So the role of ESA will be mostly as trial user, early adopter, validating the data or the service you are providing. So in that sense, this is quite different, although the mechanism is similar to other programs, the scope.
Innovation behind the companies and the people I've talked to, that is exactly what we need in Europe. Just waiting for the presentation to load. Yes. This was the first presentation of today, actually. We can switch a presenter. Yeah, okay. Suppose we do that. Okay, then let's switch a presenter. Can we do it? Yeah, let's do that. No, no problem. Okay.
Szanowni Państwo, ze względu na problemy techniczne zmienimy kolejność prezentacji. Zapraszam na scenę Leopolda Summerera z Dyrekcji ESA do spraw technologii, inżynierii i jakości. Zapraszam.
Thank you very much. Here we go. So technology, I'm going to talk about technology, and it's a very easy talk at the end of the day, because almost I think all the speakers that I heard today, they had in one of their first phrases at least once the word technology. It is technology that enables us to push what is possible for typically the science-driven Earth observation and science missions. It is technology that allows us to open new markets, new services from space, and we have a number of these in the menu for the ministerial in one month. And it is technology that allows industry to compete in this increasingly global and fast-moving, fast-evolving global space market. So at ESA, we have technology in our genes. Technology is what we do on the day-to-day basis. Technology is the thing that we think about when we get up in the morning. And we have what I hope to show you, a program, a suite of programs from very low TRL up to in-flight demonstrations of technology. And I'm speaking here on behalf of my director, Torben Hendriksen, who really wanted to be here because Poland is a success story on technology. It is, Poland really has used the facilities, the competence, and what we provide with ESA and with ESA expertise, especially in ESTEC, wisely in order to build up national competence. And you will see in this slide, which is only covering only a small part. It is the low TRL levels. It is covering what we found under the basic activities, discovery, preparation, and technology development. And in the next slide, you will see a little bit an overview. But I want to start with this slide because it covers the whole period of Polish membership in ESA. And what you see there is that it's difficult in the beginning. All these activities, they are all competitively won. So these are competitive tenders. The best is winning. And you see that it took some years to get ready to be able to be among the best of open competitive tenders. But you also see that this has really worked well for Poland. You see in the last few years and this year, and it's not yet finished, we have already 19 contracts that Polish industry has competitively won, 2.5 million. These are small contracts. Most of this is low TRL R&D activities. And what it also shows that in 2019, we changed our way of soliciting and of selecting these activities. And we opened the very early stages of the ESA innovation chain by no longer having ESA statement of works and then asking for a proposal for it, which we still continue to do, which is the bread and butter of TRP, or TDE now. We have these 2-year work plans. But we said we take away a portion of basic activity money, which we call the discovery element, And we found the most innovative ideas that are driven not by ESA, but driven by industry, by academia. And you see the effect that this had on Poland. All the blue parts are Polish SMEs that have submitted smart ideas and won this competitive contract afterwards. And we have them all running now. Some of them are already finishing. And I think it is showing you that your SMEs, Polish SMEs, you in the room, you are really doing well in this low TRL level. And this is a good omen for the next steps, because this is preparing the future. This is all activities that are not necessarily competing on terrains where others are already established actors, but preparing for future activities. Now, here is the overview of how we support technologies, the generic technologies. And you see on the left what I just mentioned, the disruptive ideas. They are outside-driven. They are industry, academia-driven. The lowest ever entry point into ESA innovation pipeline. You don't even need to have an ESA entity code in order to submit an idea. You submit only the idea in the first step, not yet the proposal. You get access to ESA experts who give you suggestions, advice, guidance, feedback, and only the most novel ideas get invited to make proposals then. And many of these activities have not ESA as a market in their business plan, but they aim for new space type markets, new space type activities. So we have now, when we saw this last year, we and Joseph created the new Directorate of Commercialization. We have naturally asked them to be part of this first step, to identify right away, when the idea comes in, what is the commercialization potential of these ideas. And we work hand in hand together with Geraldine and her and her team to then also have these activities coming from innovative new actors, helping them to get then the support that they need to do the second step after the first step, where we typically do proof of concepts. Then the second part is future missions, where we prepare the solid first baseline for new missions. You have seen just from Jorge, the Hera mission was one of those missions. Like most other ESA missions, they are first conceived there. We do the first pre-phase A, phase A studies, CDF, also, of course, open competitive. And there, of course, for new member states, it is more tricky to get a large part of it, because LSIs, the large system integrators, they have a large share in preparation. And then technology itself, the ESA-driven technology is, of course, our core technology development element, TDE, 2-year work plan. Please be attentive, because just in November we will publish the next TDE work plan for 2023-2024 with a range of interesting, challenging technology development activities which we have identified coming out of the mission preparation for the missions that are in our pipeline, and where, of course, if you win one of these contracts, then you have a good chance of getting into these future missions. And then the one step up in the TRL ladder is the core technology program of ESA, which is then optional. So this is the last column on the right that you see there. GSDP, which is the program where we go up to flight demonstrations from TRL typically 3 up to TRL 9. And I have 2 dedicated slides later on. So in the next slides, I just want to give you a few examples of Polish activities, and starting with the left column on the discovery. And this activity on quantum communication for deep space was an idea that was submitted last December on the open, actually end of November, I think, on the open Space Innovation Platform, on the permanently open channel. It was evaluated in the December evaluation round, beginning of January. They were informed that this was a novel idea. They got some feedback from ESA experts, and they were invited to make a proposal out of it. This proposal was competitively evaluated with all the others, and the activity was kicked off, I think, in May, or yeah, I think in May. So it is a process that works well, that works fast. We take some risks. It's not as thorough as a process as we typically have when we would spend millions, tens of millions, and hundreds of millions. But we are much faster, and we still follow the standard ESA rules and regulations and procurement process, but adopted to this type of missions where it is external driven and it is much faster. So then I have two activities that are within the TDE, very successful. One is looking at the reprogrammability of critical avionics. So this is developing a prototype. It goes very well. I just understood this morning that there is a follow-up coming shortly. So this is showing that you're already on board and you are developing something that is critical on board in order to have to change the algorithm on board for avionics being not only safe now, but safe once a quantum computer is there, so post-quantum encryption. And this is another activity which is also going on very well, I understood. Within TDE, it's particle modeling inside launcher fairings, so something completely different, where the next step is then to address also venting and address lunar dust. And it's, as you see, a completely different part, also modeling, also taking benefit of Polish competence in high computational load models. Now, GSDP, as I mentioned, GSDP is the main technology program. It's the a la carte program. It's the optional program. We are not changing it at this ministerial in its structure. It has served well as it is now. It is working well with element 1, the develop element, where we are about to issue new compendia. These days, maybe it's already out. If not, then in the next coming days. Element 2, make, which is open for new ideas, new proposals, outline proposals from industry at any moment. GSDP Make was one of the first optional programs that also used the Open Space Innovation Platform for the first step, which proved very efficient because it avoids sending emails. You always know where your proposal is, what the step is, and you know the feedback that you get quickly on the platform. And then, of course, element 3, fly, where we go up to in-orbit demonstrations. And what we have now for this ministerial, we have 2 new components. One is Endure, and the second one is the EEE Sovereignty Initiative. Some of you might remember the ECI program that we had 10 years back. The EEE Sovereignty Initiative is the CHIP Act equivalent that we have for the space sector. So there we want to make sure that we have in Europe all those capacities that we need, and we avoid having situations like now where over 90% of our FPGAs come from overseas, and we have many other dependencies that are just getting more and more uncomfortable. Endure is very different, but in principle, another sovereignty program, if you want. We cannot survive the lunar night. We cannot go beyond Jupiter orbit without radioisotope power sources. These are the only technically sound solutions that we have so far. And we have used them in the past, always in cooperative missions with the United States, and on ExoMars it was with Russia. And we have now a very smart European alternative that is based on reprocessing spent nuclear fuels, extracting something that is a nuisance for the long-term deposit of nuclear waste, which is americium-241. And it's a nuisance because it's has a very long half-time, and therefore it's the type of thing that you don't want to have in your waste stream. So extracting it for space, this is exactly what we want. It's an alpha emitter, and it has long half-time. So this is what we propose now, and we are confident that this will provide Europe with more autonomy for exploration, deep space, and also science missions. And the last one, Solaris, we propose it as a specific element in element 1, is probably one of the most, if not the most ambitious activity that ESA has ever put forward. It is looking at space-based solar power, which is on the books in the academic circles since 100 years. The first one who spoke about it was Tsiolkovsky 100 years ago. Since 1968, it has been proposed as an engineering concept, but it is still very, very, very ambitious. And we are not sure that this is economically viable. But it is technically possible. And given the situation that we are in, where we want to decarbonize our energy system before 2050, and the energy system is contributing with about 75% of the total CO2 contributions. What the International Energy Agency has put forward is a roadmap, what it means to decarbonize the energy system. And they call it's a complete revolution. And when we spoke to them and saying, well, we think this is technically feasible. Economically, we really don't know because we are not the best to judge. And their answer was, well, if it's technically feasible, then we should certainly look into this. And this is what we propose now. We propose a technology development program where we put forward all the critical technologies that would allow us to make a decision in 25, 26, if such a system can become economically viable by 2040. And we think 2040 is the time frame that is needed in order to make a substantial contribution before 2050. And what we have there is a technology development program for 4 to 5 key technologies that enables this, but that we need anyway. We need anyway for our exploration mission. This is about in-orbit construction, in-orbit assembly. This is about high-efficient and low-cost photovoltaic cells, and there is some very good competence in this country, for example, on perovskite solar cells, that could allow achieving this cost target. Then there is about high-efficient conversion of electricity into microwave frequencies, and then the reconversion into electricity. So there's a number of very challenging, very interesting technologies that all have interesting applications in space. So this is part of what we have there. Then 2 slides on GSDP. Polish participation has been very good. As I mentioned, Poland is a success story in how you use ESA technology programs to build up your interests, your national priorities, your competencies, your SMEs benefit from this. At the moment, it's about 2% of the overall envelope since 2012, when you joined it very early on. You see there the main areas of interest, and the picture on the upper right, I've put there HERA, because HERA was, of course, the program where we used GSDP to also fund the Polish contributions for navigation, visual navigation, and GNC developments. And these are maybe the next steps to level up, and as Daniel has mentioned in his presentation, to ignite the second stage is we are putting forward now this product portfolio framework, which is something that we think is needed by industry to have a longer-term perspective, where we have gates starting with de-risk activities that confirm that there is the capability in a certain technology development area, but then developing actually products with a stage gate approach. And microsatellite platform development could be one of these areas that could be of interest, but there are several others, and Udo Becker and his team has already been here, I think 2 weeks ago, and will come back to discuss this further. And then my almost last slide before I hand over to Marco is on something that doesn't get much visibility, but I think you have benefited very much from using also ESA frameworks to build up competence in Poland. And this is about, for example, soldering competence for space. And you are serving now from Poland and in Poland the whole market of Eastern European companies. Now, we are about to issue a new technology strategy, and it's not a tech, it's an ESA technology strategy. You will have seen in Agenda 2025 that our Director General, Josef Aschbacher, has asked us to have more industry-driven activities, to have more funding for game-changing activities, and he has asked us to put an increasing focus on the faster introduction of novel, new technologies into space missions. So in-orbit demonstrations, faster in-orbit demonstrations, faster development and demonstration of new technologies in orbit. And he has asked us to initiate 3 new technology initiatives, which are all now in the new technology strategy, which is about to be made public in the next days. One is on quantum technologies, where we already have a white paper published, and Poland is very well represented in the key technologies that we have put there. Second one is on advanced propulsion, and you have very good competence also in this country. And third one is on in-orbit servicing and construction. And with this, I hand over to Marco, who hopefully has his presentation ready. And I'm here for any questions, of course. Thank you very much.
Dziękuję bardzo. Thank you very much. Before we go to Marco, zanim przejdziemy do prezentacji Marco, chciałam zapytać, czy pani Giulietta Kajsan jest na sali? Is Juliet here in the audience? Yes, so could we actually switch to your presentation before Marco? Yeah, thank you. Zapraszam na scenę Giulietę Kajsan z dyrekcji ESA do spraw badania kosmosu przez ludzi i roboty.
The stage Juliet Kajsan from the Directorate for Space Exploration, Human and Robotic Space Exploration.
This one is to go. Okay. Sorry for this change. No problem. Okay, thank you so much for having me. My name is Juliette Kajsan. I'm from the Coordination Office of the Human and Robotic Exploration Directorate. And I'm very honored to present to you today our ambition and challenging program, Terra Nove. I'd like to start with this first slide and to draw your attention to the scale here below in order to better understand the challenges we are facing. you see at the bottom of the slide where we are on Earth. Around is our first destination at HRE, it's ISS, which is rotating around us. And then the Moon is a second destination, and then Mars is a third one. So have a look to the distance, and even on this slide, I think it's vertiginous. So what is Terra Novae? Well, our program is the main tool for turning the goals and ambition of our strategy into reality. The overall objective corresponds to a long-term vision to be implemented in a stepwise approach. And the current program is in a full swing and accelerating to safeguard Europe's interests and ambition in exploration for this decade. And you can see this slide is consists of two parts. There is a current decade, 2020 to 2030, where ESA is in a mutual interdependence. And what we want to achieve is, by the next decade, a European-led capabilities. And how we do that, if you go at the bottom, and we are back to the human in LEO, we are ESA, a core ISS partner, and we are already preparing the post-ISS and the commercialization of our station, with the ambition to have a cargo, launch and return, and independent human transport. If we go now up to the human beyond LEO, we are already in the Orion program with the delivery of European Service Module, the delivery of 2 modules within the Gateway, but the ultimate goal is to be living and working on the Moon. And if we go one level up, you see our ExoMars mission, 2016 and 2022, the Mars sample return with the goal to be preparing to send human to Mars. So we endeavor to do the right stuff by implementing national ambition while following a realistic and shared strategy, building essential capability for sustainable exploration. And sustainable is a key word in our program. We want also to be stimulating the development of commercial services and leading to a Europe autonomy in selected areas to become even stronger. Of course, this goes along with benefit for Europe in several domains, science and knowledge, having a growing competitiveness of our industry, and we want to further develop international cooperation to become an inspiration for the new generation and become a leader in the exploration. With still a goal in mind, and we achieve that with a strategic resilience. And our strategic resilience consists of 4 pillars. There is the continuity, the sustained presence in and the utilization of the low Earth orbit, with the ambition to have Europeans on the Moon by 2030, the vision to have our European on Mars by 2043, and the inspiration to have cargo, crew transportation, and sample return mission. But today, where are we in terms of endeavor and ambition? Well, our program is propelling Europe into the new era of space exploration. You see here again our 3 destinations, the ISS, Moon, and Mars. We will continue the ISS operation, hopefully until 2030. It's a decision to be taken by the CMIN in a few weeks. But we will prepare to go to the Moon. We have already, if you see at the bottom, we already plan to fly ESA and NASA astronauts thanks to the ESM. We are building the first Moon research station with IHAB and ESPRIT. And we want also to land on the Moon with the EL3, and that we call also Argonaut. And of course, we are already around Mars with the TGO, but we want to go further. We want to have a sample return, and we will complete the research for life on Mars with the Rosalind Franklin mission. So if I zoom in, and if we go back to our first destination, which is the ISS, well, we still foresee the operation and the utilization up to 2030 with astronauts. We will have mission each year, as you can see, 2022, 2023, 2024, and 2025. And of course, we have to prepare for the commercialization. We have already a long duration mission. You can see 2 missions last year in 2021, the Alpha mission with Thomas Pesquet, the Cosmic Kiss mission with Matthias Maurer, Samantha Cristofori, we just came back, and Samantha was the first European woman ISS commander. And now we are preparing for the new mission of Andreas Mogensen in 2023. So what does it mean, the continuation? Actually, our contribution were on structure and logistic element, on outfitting in the Columbus Lab, ERA, the European robotic arm, and the commercial platform such as Bartolomeo, but also IceCube. And of course, well, in-orbit operation are at the service of science, and Terra Nove provides a broad portfolio of research platform and opportunity, which is reflected in the SciSpace activity, which cover a wide range of life and physical science disciplines. Most activities are within the ISS, but not only, as you can see. On the next slide, we have the 4 elements of the SciSpace, mainly for ISS, but we have also to use them now beyond LEO for Gateway, Moon, and Mars. Some other nice activity to give you an idea of what SciSpace is. Bed rest. And of course, we will achieve that with our astronaut and a new class that will be announced at the end of this year. So the moon, in a nutshell, well, Europe needs LEO for utilization and low Earth orbit. Europe needs LEO for utilization and exploration preparation, and also post-ISS. We have to prepare the post-ISS era, as already started with international trend of commercialization. There will be no agency-owned platform. Instead, we will buy services, and therefore the transport model is fundamental. So now, if we go to our second destination, actually Europe has already entered in a new era of lunar exploration. You can see at the left side of the slide, we have this cislunar transfer vehicle, for which we have completed the preliminary requirement review. We have the Orion Europe service module with already the ESM-1, which is in launch preparation, hopefully this year. The ESM-2 has been delivered already, and ESM-3 and 4 are in manufacturing. We will deliver 2 modules on the gateway, the Esprit and the HiHab, and we have here a very interesting project, which is the SSTL Lunar Pathfinder, which is in development, and SSTL will provide ESA services and also to NASA. And in exchange, we have signed an ESA-NASA MOU, meaning that NASA will barter the launch for services. Of course, we continue the Moonlight studies. And if we had to discontinue the lunar cooperation with Roscosmos, we are trying to have a second change for the pilot D we call LANCAM-X, and the commercial flight demo is in negotiation. And of course, we want to bring stuff to the moon with the European Large Logistic Lander, but this has to be decided at the ministerial. A few details on the Artemis update. As you can see, ESA is now a real senior partner to NASA. You see the logo of ESA on the Orion and the ESM encapsulated to a NASA rocket, and hopefully the next launch will be successful on the 14th of November. Again, some further details on the cooperation between ESA and NASA. So we have the ESM-1 foreseen this year. In 2 years from now, the crewed flight test. On ESM-3, the moon landing, and ESM-4 will deliver IHAB to Gateway, ESM-5 ESPRIT to Gateway, and ESM-6 in 2029. This will bring 3 ESA astronaut flight opportunity to Gateway to ESA. And you see our partnership has increased because we represent now 50% of the module on Gateway. But again, if we talk about reality, we have already a lot of robotic exploration ongoing on the moon surface thanks to the mission opportunity. We have Prospect thanks to Astronica. We have the Pilot D, or so-called now Landcam X. We have the commercial exploitation and transportation, the exploration mass spectrometer. The AMS launch is foreseen on a NASA Astrobotic Peregrine lander planned for end 2022, and the AMS LUPEX MOU, which was signed this year with JAXA, and also the negative ions on the lunar surface and the laser retroreflector. So, but for that, we need to bring stuff to the moon, and our ambition is to have a European lander. It is proposed as a series of missions and not a one-off. As I said, sustainability is a key word. It will represent a valuable contribution to the lunar vicinity. It will offer an independent access to lunar surface. Our project is fully coordinated already with NADA that is supporting this proposal and will find useful if ESA proposes this kind of contribution. Again, it's about sustainable exploration of the moon to get there and regular activity on the long term. So in a nutshell, about the moon, it's regular and substantial robotic access during the 2030s, enable a European-led scientific and logistic activity. It's about reliable and visible partner for sustainable exploration of the moon, and the ambition is the first European on the surface by 2030. So now from the moon to Mars, this is our third destination. We have already, as you see, the TGO continuing producing science and serves as a data relay for insight and perseverance. We have the Rosalind Franklin mission proposal in cooperation with NASA to be decided again at CMIN 2022. We have also ERO is in phase C development, and we had to discontinue the sample fetch rover, but we still have the sample transfer arm. So that's a nice picture of what could be the future. A graphical view of Rosalind Franklin. And that we always like to use latest picture taken by Cassie on TGO. This is a picture of Mars. Here again, we are a big partner from NASA because we will represent 20% of the partnership. You see here ERO and again the sample transfer arm. So Mars is, in a nutshell, well, the robotic mission are to consolidate key capabilities, to continue the search for life, to secure European independence of action at Mars. The future possible mission studies as part of EXPERT, and in synergy with LEO and Moon position Europe for a strong contribution to the human journey in the 2040. So we will be very busy this year. If I start at the bottom, you see the several ISS missions I mentioned already, the COSMIC KISS, the Alpha mission, Minerva, then this year the first launch of ESM-1, then the open competition for ISS service in period 3. We are expecting the new astronaut class. Then there will be the ISS astronaut mission from Andreas Mogensen in 2023. ESM-2, ESM-3, further ISS astronaut mission, hopefully to be decided this year, the Rosalind Franklin launch in 2028, with a landing 2 years later in 2030. then further followed by ESM-4 plus IHAB, the MSR Hero launch on Ariane, ESM-5, the MSR launch, ESM-6, MSR Hero, and to be decided again this EL3 or Argonaut. So again, we explore, but you benefit. This is a benefit for Europe in terms of science, knowledge, and economic, of global cooperation, exploration, preparation, and science, and inspirational that we have to be. So very quickly, again, I show you the first slide I use. This is where we are, 2020 to 2030, in a mutual interdependence, and we want to achieve an independence and having a European-led capabilities. This is an ambition perspective for the current and the next generation. And this is why we are asking for a substantial budget, as you see, but actually most of the budget required is to cover the obligation of international commitment, plus utilization of those commitments. And we have the new project, Rosalind Franklin Recovery, the EL3 lander descent elements, and the space resources demonstrated during Phase B. And we want to prepare the future with the experts system study, the technology for future, and the business in space growth network for commercialization. So that would be my last slide. Once explorer, always explorer. I think this is the case of Poland. We are talking this morning of 500 years of history, so I wish you another 500 years of exploration. Thank you very much.
Dziękuję bardzo. Last but not least, zapraszam na scenę Marco Falcone z dyrekcji ESA do spraw nawigacji.
From Navigation Directorate.
Maybe you can put it under the computer, normal as before, under the form without the display mode. Funziona. Yeah, thanks a lot. Okay, thanks a lot. It's an honor for me to be here. I met a lot of companies, very good institutions, and I will be available later on this evening and tomorrow for any talk in order to increase the competitiveness and the innovation of Europe in navigation. So let me say first that Europe is really leader currently on navigation, on satellite navigation. The flagship programs we have in ESA together with European Union are the Galileo program. If you want, when Poland signed the agreement in 2012 with ESA, we were busy in October with the second launch of the Galileo constellation, and now we were putting in orbit the third and fourth satellite. Now we have 28 satellites in orbit, a system that is used by more than 3.5 billion users. And on the EGNOS side, that is the satellite-based augmentation system of GPS today and also Galileo in the future, we have more than 360 airports using the system with more than 1,500 procedures in place. So quite an achievement. But the market that is behind this is massive. Just to give you an idea, we have an exponential growth of location-based services. We see it, we all, I think navigation is a very clear example of the benefits of space. We see this every day. So I give you just 3 numbers. More than 10 billion users there will be by 2031. There will be almost 500 billions of downstream, and this is the position navigation timing services represent almost 10% of that of the European economy. So a really very important sector, the navigation, for the mankind, for all citizens. What is the market looking for? We see it again in our everyday life. People want to have more accuracy. People want to have continuous availability, resilience. They rely on the system. So when my phone is not giving me a position, I want it. I want it now. There are autonomous vehicles, so we will need to have signals also that they have a high degree of integrity, and also integration with terrestrial networks, 5G, 6G, always connected. So in order to have a continuous connection for positioning and communication. Is also the previous director of Telecom and Integrated Applications presented, actually. The objectives are very clear and integrated together. So we are leaders. But how to maintain this leadership? This is very important. And leadership can be maintained through innovation. Innovation is fundamental. First of all, we need to train people. We have done this in cooperation with Poland. We had in summer this year in Krakow a summer school of global navigation satellite system. This has been done in cooperation with the Polish Space Agency and the University of Austin. It was very successful. We had a high number of students, you see there. More than 50 students and representative from all over. So very, very powerful means to train the engineers for the new developments we are going to have. Innovation also for having research and development activities. And this is here that I want to present the program for our ministerial council that will take place in November, where basically we have a menu that is made of a NAVISP research and development program. I will address it, the phase 3. And the Future Nav program with the low Earth orbit positioning, navigation and timing demonstrator and the Genesis mission. All accompanied then also by the Moonlight initiative that both Juliette, the colleague before me, and also Elodie from Telecom and from Human Robotic Exploration explained. This is a partnership very important. So first, NAVISP. NAVISP is a research and development program. Is made of 3 elements. There is a first element that is basically to really oriented to innovation, new technologies. For this, this is funded by ESA. A second element that is really to make industry competitive, and this is co-funded by industry and by ESA. And the third element where basically ESA is supporting member states' initiative, also then funded by ESA, but in direct relationship with the delegation and the industry proposing this activity. This is a sort of a success story, as my colleagues presented success stories before. As you can see, there are a number in NAVISP of activities that have been done in Poland with around 3 million euros budget that has been completely used for mainly element 2 activities, for very interesting applications. For instance, software receivers for GNSS, for micro launchers and micro satellites, but also also applications for users, for citizens, like geolocalization services for medical emergencies, support of information for touristic destination selection, trip plannings, also support to safe navigation in harsh water environments. Navisp, now with a phase 3, provides a number of opportunities for industry that can be really exploited. It is a very easy vehicle to use and very effective. FutureNav is preparing the future of European GNSS. It consists basically on two types of missions. The first one is the low Earth orbit positioning, navigation, timing component with satellites in low Earth orbit. And for a budget, we are aiming to a budget for the ministerial of 100 million euros and 80 million euros for the Genesis component. Then the low Earth orbit positioning, navigation, and timing is really oriented to meet the market needs I was identifying before, in order to be innovative, to be able to have those technologies on board the satellites that meet the user needs. For this, today we have Galileo that is in medium Earth orbit at 23,000 kilometers above the Earth. And we are going to put in place a so-called multi-layer system with satellites at low Earth orbit that complement the satellites in medium Earth orbit, and then also that integrate with a terrestrial component of 5G, 6G. This is the future in order to have a backbone system that ensures the resiliency and the robustness at a medium Earth orbit, and then the services, value-added services provided by this constellation. And this is a demonstrator because we want to make European industry competitive. So it is important to demonstrate this capability. There is a lot of interest in worldwide for this type of constellations. There are a lot of initiatives also by European industry, private industry that is asking for this type of programs in order to be competitive on the market. And this is what this program is for. Genesis is a different ballpark, is more scientific type of mission. The objective is to be able to model the geodetic terrestrial reference frame with 1 millimeter accuracy. And this is obtained through combining on the satellite different techniques for positioning, typically like receivers, GNSS receivers, very large base interferometry payload instruments, Doppler orbitography instruments, and laser retroreflector. By combining together this type of observation, you can, through the same satellite, get down in terms of precision in estimating the terrestrial reference frame. This has concrete application. My colleague Simonetta Kelly presented today, for instance, the importance to model the sea surface. The sea surface is evolving of the order of 3-4 millimeters a year due to the global warming. How can you model or measure so precisely sea surface if you don't have a terrestrial reference frame with an accuracy of 1 millimeter? So it's something that has not only a direct impact on navigation and geodesy, but also on earth sciences. And this is absolutely very important. In terms, we have issued requested for information through summer in order to gather for FutureNav the feedback from the industrial players on what is their interest in order to join these programs. And we have closed all of this in September timeframe, and now we are in the context of doing clarifications. Let me elaborate on it. For the low Earth orbit, we have quite a strong interest, because many countries, in particular Poland, expressed interest as a subcontractor supplier for this type of technology. It's clear there has been a lot of interest. I think we have received more than 60 to 70 notification of interest. And confirming absolutely the objectives I was identifying before in terms of user. And also what has appeared is a lot of interest from SMEs and new space type of companies. As an example, I'm just here quoting some examples from companies we have talked to in these days. GMV Innovative Solutions was offering a payload on board integrity monitoring unit, and an interest on that. That is a very interesting type of payload, for instance, to support the autonomous vehicles I was discussing before. Or Creotech was proposing their Hypersat satellite platform for this type of missions, because is really a good candidate. We are targeting from Poland a contribution for platform of the order of 5 million euros. This is the target that we are looking at, and 2 million euros for the payload. So it's a very interesting program, I think, for Poland to participate in, with a concrete return on technology. Genesis, we have had interest from a number of countries. The notification of interest covered all the instruments I was mentioning before. This is very important. Interest for their usage. Additional payload on board the spacecraft in order to have a global, worldwide partnership for this very ambitious objective, that is to model the terrestrial reference frame. In terms of equipment suppliers, I list here a number of companies that we see from not necessarily from the notification of interest, but as a potential candidate, in my view, for implementing equipment at the level of a satellite. But also I want to stress the importance of a scientific contribution, where Poland is absolutely an excellence in this field, because Wrocław University, for instance, they are part of a Genesis white paper that we have written for the exploitation of the data of these satellites, or the University of Varmia in Missouri. They are member of a GNSS scientific advisory committee, and they gave very important advice for making this mission. And then, of course, CBK, that was mentioned here, and the head office of geodesy and cartography and AGH. These are elements that I introduced here. There were not direct interests expressed, but I think is important because this is a very interesting mission that allows to put together the experience of the academia and the institutes that there are in Poland and the competence of the industry. We target a budget of around 1 million euros for industrial activities, and to be defined for scientific. That is not only limited, scientific is not only limited to providing advice and guidance to the mission, but also it is associated with exploitation of the data. For instance, or provision of stations. There are laser ranging stations in Poland that could be used, and data processing centers and scientific expertise for the exploitation of the data. This could be very valuable, in my view. Moonlight, as been mentioned by Juliette, is clearly is a very interesting to see the number of activities that are going on to go towards the moon and beyond. And it's clear that all these missions, they will need communication and navigation. Is a precondition for these missions. And given the number of missions, I think Juliette's presentation was very clear in this, on the number of missions going to the moon and beyond, there is the interest for having such a system. This would be a dedicated constellation of satellites around the moon. Basically is a global navigation satellite service and communication service orbiting around the moon, providing positioning, navigation, and timing capability. ESA, in this case, would support the infrastructure development, but at the same time be anchor customer with their missions to use the system. And then clear, this is a very strategic initiative for the 20 years that would be at the disposal of all the players going to the moon. Is a natural evolution, I think, for being leader on the Earth, and with the activities of navigation we are doing with Galileo, for instance, and EGNOS now worldwide, to move these activities towards the moon and beyond. So let me conclude saying that, okay, it's clear that Europe is a leader in their field, or is, I think when we started this more than 20 years ago, with Galileo and EGNOS, there was clearly GPS was the standard. Recently, in the last years, we see that, for instance, in the Institute of Navigation Conference in the US, there has been a clear recognition of this leadership by all the users, by the market that you see is growing exponentially. We have to be very proud of this. And then, but we need to keep this competitiveness. And this is why these type of programs are very important. And to be competitive, to be fast, is needed to have SMEs and competitive industry, new space technology that in Poland is available. So I think this type of programs, especially for Poland, represent a clear opportunity. And this, with this, let me conclude my presentation. Thank you.
Dziękuję bardzo. Szanowni Państwo, poznawszy wyzwania ESA na nowe czasy, zbliżamy się do zakończenia pierwszego dnia konferencji 10 lat Polski w ESA, wczoraj, dzisiaj i jutro, organizowanej przez Ministerstwo Rozwoju i Technologii, Polską Agencję Kosmiczną oraz Związek Pracodawców Sektora Kosmicznego. W tym miejscu chciałabym podziękować wszystkim gościom, licznej reprezentacji dyrektorów z ESA, panelistom, moderatorom, a także, to może będzie zaskoczenie dla co niektórych, tłumaczom języka migowego, którzy w tle wykonywali świetną robotę. I ciekawe, w jaki sposób przetłumaczą te słowa, ale chyba sobie poradzili. Rozmowę o przyszłości sektora kosmicznego w Polsce i Europie kontynuować będziemy drugiego dnia konferencji, na który serdecznie Państwa zapraszam. Spotykamy się w tym samym miejscu jutro o godzinie 9:30. Dziękuję Państwu za obecność i życzę owocnego wieczoru sprzyjającego, miejmy nadzieję, dyskusjom oraz wyznaczaniu celów na przyszłość. Dziękuję.